take 15 seconds. So it is live on YouTube. So now you can formally start, Nagisa, please.
Thank you very much. Thank you, everybody. I see some delegates from outside the university and across India and foreign countries. So I thought it proper, while we are waiting for our chief guest to join us, I'll take a minute or so to talk about MS Swaminathan School of Agriculture at this university. And later, I think our Chancellor, Honorable Chancellor, would also be talking about Shoolini University. But in the meantime, while we are waiting, I think uh, I like to highlight the focus areas of the School of Agriculture at this university. As we all know, we are situated in the mountainous area, Himalayan region, Western Himalayan region. So our main focus is on mountain agriculture, making it sustainable, and also looking into the options through which we can improve the livelihoods of small and marginal farmers of hill areas. Most of you must be knowing, and I see some foreign delegates also. I see that in their areas also, we have almost similar kinds of conditions. So small and marginal farmers, they are hard pressed because of the resource constraints and also because of the climatic constraints to get the livelihoods or the get incomes which will sustain their families in an honorable manner. Right, so this is a responsibility that Shoolini University has taken on itself to do research, go deep into the problems of farmers of mountain areas and the problems of mountain farming systems, how these can be sustained in the times to come. One of the challenges that we are facing here is the climate change. We all know about this. Himachal, of course, is known for horticultural crops and particularly apple. But because of the climate change, where we are getting low rainfalls, low snowfall, and the pattern of rainfall and snowfall has also changed dramatically, as a result of which the areas which were suitable for a particular crop, that niche area is now shifted. It's shifted to some other higher reaches, or those niche areas are no more suitable for cultivation of those commercial crops, which the farmers were taking at a small level. So we have a challenge here, how to address these problems. Over and above that, we also have a problem which is arising out of the climate change as well as because of the human action, that of losing of our fertile soil. Climate change, we all know the soil erosions, landslides, and other things, they are creating havoc in mountain areas. But at the same time, the human actions, in terms of the way we are now utilizing our uh, land resource, we are putting so much of chemicals in there, and also the water resources which we are using for irrigation, they are also polluted, and polluted not only because of the mud and what do you call this uh, material from forest, but it's also polluted because of the many industrial chemicals which are coming to those water resources, and the farmers have no choice but to use those resources. And this is a tragedy in hill areas. Hills were known for clean water. Hills were known for perennial streams of water. Hills were known for the waters which had minerals in there. But instead of that, those minerals and other things, we now are facing a dramatic problem which we all need to address in this discussion. And at Shoolini University, the MS Swaminathan School of Agriculture, which is named after the legendary agricultural person, Dr. MS Swaminathan, who is also known as father of Green Revolution in India. Uh, we are we are young, of course. We are only in the fourth year of our existence, but at the same time, we are trying our best to address these problems by going to the farmers and talking to them, and also uh, gearing our research programs to meet those ends, research ends. And in that respect, I feel that today's discussions, they are also very important, because the water resources are crucial to hill areas. We have plenty of water in the hills. I don't say that we don't have water. All across the world, we see that mountain areas, they are surrounded by water resources. But in order to economically use that water, lift that water, it's not cost effective. And hence we have to look into the ways through which we can conserve water resources at a particular stage in the areas where small scale farming is being done by the farmer. And we have to see that these water resources are not polluted, and they in fact are getting polluted, and also they are drying up because of unscientific use of water as well. I can say that to some extent. So we have to find out ways where the water is used optimally, um, where we can get more crop per drop of water. And that is what we are targeting at School of Agriculture in Shoolini University. And we'll be collaborating with other sister universities around us in order to meet that broader goal of sustainable mountain agriculture. And let me add here, of course, our Chancellor, Dr. P.K. Khosla, is authority on it, that we have to give special consideration to conservation of forest and propagation of forest, which will allow us to look into this problem of water resources and conserve and augment water resources for sustainable and remunerative farming in the hills. And that is what I thought I'd like to say as a prelude to today's vertical workshop. And I'll hand it over to Dr. Santanu now.
Okay, thank you, sir. Thank you for your nice talk and very didactic information. I want to say very good afternoon to all of you. And just a little brief about me. I am Dr. Shantanu Mukherjee. I am working as the assistant professor at School of MS Swaminathan School of Agriculture in Shoolini University, and I am conducting this seed grant project with Lancaster University, UK. So as we know all that today is the World Nature Conservation Day, and our Honorable Dean Sir has already mentioned that why we need to conserve our nature and also particularly the Himalayan ecosystem, because it is very fragile. So now I think the event that we are going to organize today is very aptly it's the correct time for organize this event. So now I would request our Dean Sir, our respected Dean Sir, to introduce our Honorable Vice Chancellor Sir, who is with us, and then we will be happy to hear it address. So, sir, please you.
Thank you, Dr. Santanu. Good morning and good afternoon, all. And I think I should again thank you, Dr. Santanu, for letting me take this digression from the circulated program, where I thought it proper that once we hear these luminaries today, the keynote speakers and the guest of honor, we should also know a bit about them so that we understand the feelings and the focus that they are having in their approach to education, in their approach to sustainable agriculture, and in their approach to development of society at large. And it is in that regard that I wish to introduce our Honorable Chancellor, Vice Chancellor, Professor Atul Khosla, to you all. Professor Atul Khosla has been a successful entrepreneur for past few decades. And before venturing into educational field, Atul is an alumnus of prestigious IIT Kanpur and Jamnalal Bajaj Institute of Management Sciences, Mumbai. And he started his career with the renowned McKinsey & Company and has founded and led multiple startups since then. Atul founded Everest Group's businesses in India and Asia back in 2003 and 6. Subsequently, he moved to Switzerland, and where he helped build a global consulting business. In 2008, he founded Oliver Wyman's India and Asia business. Atul also advises several Indian and global organizations on issues of strategy and innovation. He has been independent director with Gabriel India, director with InnoHive, senior advisor to Ankur Capital, which is India's leading venture capital fund, member of HP Council CII, Confederation of Indian Industries, and advisor to SEBI, which is a very important post. SEBI is India's security regulator, and many other positions that he is holding. Prior to joining Shoolini, Atul was MD and CEO of Oliver Women in India. As founder and trustee of Shoolini University, Atul is now promoting higher education with a focus on reaching the underprivileged students in the state, particularly the state of Himachal Pradesh that I'm talking of, state of Himachal Pradesh in India. To meet these goals, he has been working hard to create appropriate environment and generate resources. And as a result, he has been a regional vice chair, National Education Council of Associated Chambers of Commerce and Industry of India, member Northern Region Committee on Education, and member CII and Northern Region Committee on Life Sciences and Biotech. Recently, Atul also founded one company which is called ADO. It is an edutech startup based out in Chandigarh in India. And I should say that this has transformed the education system, particularly the classroom experience that we are having in education in this part of the country. And this experience, which is totally a changed experience, I believe and I'm confident is going to further transform the education that we are having, particularly online education. And it has taught us many new ways to look at education during this crucial pandemic period. And with his vision and effort, I'm sure that in times to come, not only this university, but universities in this particular region, northern region of India, and maybe across the country, would see a total transformation of how online education or virtual education can be equally effective, I should say, in promoting the cause of education at large. With these few words, I'll invite Professor Atul Khosla for his address today, please. Thank you.
Thank you very much, Dr. Negi, and I truly appreciate, such wonderful words from such a luminary and respected and educated person like you. So I blush as you speak all these wonderful words, but thank you very much. The topic is very apt for the presentation today, but before that, let me welcome all the participants here today. We also have our Chancellor, Dr. Khosla, with us, and I can see Dr. Shantanu, Binoy Sarkar, Satish Gupta ji, Sarvana, Pradeep, Amit, Kamal, and many more. Pankaj Raizada, so Dr. Sharma, GK Sharma, Saurabh, Kulshrestha is there. So welcome to this wonderful seminar, and it's my honor to speak to you today. If I speak too long, I'll be speaking to the popes. You're the ones who understand science way more than me. I'm more of an economist and management consultant. So for me, the topics of science are a little more difficult to comprehend, but being a social scientist, I would like to mention 3-4 things. First, we've been talking about water, and I've been reading a lot about water, and I've worked on water for a very long time. I remember in 2009, when I was in Switzerland, Syngenta, which is one of the largest biotechnology companies in the world, had hired me and my team to work on what they call the World Water Strategy for Syngenta. So Syngenta is based out of Basel in Switzerland, and I used to have large number of discussions with the CEO of Syngenta, the global CEO of Syngenta. So as Dr. Negi said, water is a big issue, and for firms it was a big issue. And what Syngenta, a firm which is a seed company like Syngenta, believes that water can be monetized, which means you can actually become rich if you can solve for the problems of water. Future wars are going to be on water. In fact, we already know that Telangana and Andhra Pradesh are fighting on water, and the government of India had to intervene. So water becomes a very important part of our lives, human beings and living beings in general. The difference between Mother Earth and the moon and Mars is actually water. So water is very precious. So let's spend 3 minutes on water. So do we have less water than what we used to have, let's say 100,000 years ago? So does Earth have less water? Actually, the answer is no. The amount of water that we have on Earth is pretty much the same as it used to be over centuries or even hundreds of thousands of years. The problem with water is the number one, the equal distribution of water. So there are some places that have large amount of water and there are floods, and there are some places where there are droughts because there's not enough water. And in some places it might be there might be snow because water is in a different form. So the first challenge about water is how do you distribute water in an equitable way? How does everyone get access to water? And if you don't have access to water in the same equitable way, then how do you transport water in an efficient economic way where the wastage of water is limited? So let's take the example of Abu Dhabi, for example. No water over there, or no drinking potable water there, lots of sea water there. So their challenge is how do we either convert seawater into potable water, or can they get other forms of water over there? So what are they doing? Uh, they've got great converters to convert seawater into potable water. That's one. And there's some experiments to even bring in glaciers. Just tow glaciers to places where you don't have enough water. So experiments are happening. I think the important thing as scientists we need to understand is economics of such a process. So many times we work on the science of it, but we ignore the economics of it. So economics is very, very important. So that's the first message I'd like to give. So that's the first thing. How do we distribute equitable water all across the world? I think the second big challenge is around pollution, which I think is the topic for today. Pollution is one of the biggest issues of humankind. While we have water, this water is getting polluted, and it's getting polluted very fast. Of course, the different forms of pollution is coming through industry, it's coming through sewage, it's coming through other heavy metals and other things, bacterial activity, viral activity, etc., etc., etc. So the question we again have is, number one, can we prevent pollution? That's the first thing. So can we produce products without pollution? So that's upstream. And if water has been polluted, how do we again efficiently and economically, again repeat, economically, we're able to treat water in a way that it becomes unpolluted? So ultimately, economics comes in everywhere, because if we can't do it economically, it's of no use. We won't be able to do it. So again, I'm going to talk a little bit about economics and social impact. So I was in Germany for many, many years, and there's a beautiful river called the Rhine in Germany. And Rhine, like the Yamuna, or the Jamuna as you call it, used to be an extremely, extremely polluted river. It had all industrial waste of Germany being thrown into the Rhine. And the scientists had worked very, very hard to unpollute the river Rhine. They couldn't. It was as dirty as, let's say, the Yamuna today. Till one day, there was a brilliant idea by a social scientist. So the social scientist basically said, let's understand how industries are using and polluting the Rhine. So you understand the concept of upstream and downstream. Let me explain. If the water is flowing down, anything that's up is upstream, and anything that's below the flow is called downstream. You all understand that. So historically, what would happen is industries would pick up water upstream and throw pollutants downstream. So you're picking up clean water upstream and you're throwing polluted water downstream. So a social scientist came up with the idea. He said, flip it around. Industries will not be allowed to pick up water upstream. They'll have to pick up water downstream and throw pollutants upstream. So if you were an industry and you were not cleaning your water before you threw it into the Rhine, you would be picking up dirty water. So just by one social behavior, one policy, they cleaned the Rhine. I'll again repeat, they tried many, many years using science and technology to clean the Rhine. They couldn't clean it. But by switching upstream, downstream, they cleaned the Rhine, because if I'm an industry and if I throw my pollutants upstream and I'm picking up water downstream and I have not cleaned my water, I'm going to pick up dirty water, as plain and simple as that. So my incentive has to clean the water. So just by one simple thing, they were able to clean the Rhine. The message I'm trying to give is that all of you are biology scientists, chemical scientists, agriculture scientists. Many times when we get into research, we forget the economics of science, and we sometimes ignore the social aspects of science. How will our science be implemented? So keep that into play. Pharmaceutical products and uh, consumer products are huge pollutants, especially in Himachal. The whole Baddi Baroti Wala belt is one of the largest producers of pharmacy, or it's called the pharmacy of India. A huge amount of pollutants are actually being thrown into water bodies. And I think it is our role as a university to help them, guide them, support them in unpolluting these water bodies, because if these bodies are not unpolluted, if they are not made clean, over a period of time, even the industry will die because they need clean water to survive. So, once again, what a wonderful discussion. I'd love to hear the deliberations, the proceedings. Hopefully, the organizers will produce proceedings of this wonderful seminar. I'd love to go through the proceedings. And I think let's implement some of those proceedings at Shoolini. I think we are also users of water. We are also somewhere pollutants of water. We are polluting water through sewage, though we try very hard to recycle our water. But I think we need to make it more efficient. We need to make it 100%. And like Singapore, we should be in a position at Shoolini to drink our sewage water. So I'll be the first person to volunteer to drink sewage water, Dr. Negi, if you can get quality recycled water, and I'll be the first guinea pig for that. So with that words, I once again welcome all of you and challenge all of you to come up with economical, social, and beneficial products and sciences for the community so that we can change the world together. Thank you, and over to you, Dr. Negi and others. Look forward to your deliberations. Thank you.
Thank you, Professor Atul. Thank you very much for that insightful thoughts. So, Santanu, do I move to introduce Professor Khosla, Dr. P.K. Khosla?
Yes, sir. Just
okay.
Yes, sir. Of course, sir. Just a minute, sir. I just it's a thank you, Professor Otul, sir. It was really a very nice talk, and really thanks for your message. And I am pretty sure that we all get enlightened by your such thoughts. And of course, we will be happy to implement this in our university with your full administrative support. And I am pretty sure that what we are getting now, with this, we will be happy to move forward. So now I would request our respected Dean sir to introduce our Honorable Chancellor sir, Professor P.K. Khosla, and we'll be happy to hear his address.
Thank you, Dr. Santanu. I think I'm not in a position to fully introduce a legendary man like Dr. Prem Kumar Khosla, but I'll try my best to formally summarize his achievements as well as his lifestyle in few words, if I can do that. Professor P.K. Khosla, Prem Kumar Khosla, is an alumnus of Punjab University, Chandigarh, India, and Oxford University, UK. He is a legendary figure in the field of higher education, particularly in the field of higher education in forestry. He is a luminary in the field of forestry education in the state and in the country, where he was responsible for setting up forestry colleges and degree programs in forestry in Himachal Pradesh. After long discussion and policy manipulations and formulations at the country level. It was the first college in the state of Himachal Pradesh was started in Dr. Y.S. Parmar University in the state, first forestry college, I should say, right? And Dr. Khosla had an illustrious professional career and held several prestigious positions, culminating into the position of Vice Chancellor at the State Agriculture University, Palampur. His contributions as Vice Chancellor of the state agriculture universities are well known to all of us here. Later on, he was also the advisor, scientific advisor to the state of Himachal Pradesh, where he was instrumental in formulating the policy, biotechnology policy for the state, and also attracting the biotechnological, what you call, industries into the state. Dr. Khosla is highly spiritual personality and is passionate about conserving and augmenting natural resources. He found it to achieve that goal, and in order to focus the attention of people to achieve that goal, he also founded the Indian. He also founded the Tree Scientist Society for the state in the state of Himachal Pradesh, right? In his focused approach that made him commit all resources to create globally competitive university, the Shoolini University, we have seen that how the focused attention and the focused, what you call, action plan can result into a highly competitive entrepreneur. And that in case of educational sector is Shoolini University, which is a good example of what a person can achieve if he or she is dedicated towards a particular goal. He has opened his heart about the ups and downs of his life journey, because everybody gets those kind of ups and downs. In his recent book, The Trust with Karma, which was released by Ambassador Vishnu Pratap, I encourage each one of us to go through that book, and maybe we can also get few lessons out of that. His thinking and approaches have been ahead of time and result oriented. No wonder Shoolini University has set a goal for itself to be a global 200 university by 2022. And this is no mean goal, and this is, we are almost there. If we see, I think Dr. Khosla would be talking about some of the achievements of the university. If we see some of the achievements of the university, we can reassure ourselves that we are almost there. I'm sure that with his dedication, with his guidance, with his what you call approach that he is taking, with his suggestions, and with his patting of the back of each and every worker that who comes to his contact, all those persons will get benefited. And at this university, I'm sure that we will be getting the goal achieved by 2020. With these few words, I will request Honorable Chancellor of the University, Professor Prem Kumar Khosla, to deliver his address, please. Thank you, please.
Thank you very much, Dr. Professor Negi. My other colleagues, Dr. Santanu Mukherjee, Dr. Gupta, Kamal, and all other colleagues which I am not able to see, who are participating and attending the workshop, webinar. I find that people from outside the country are also participating. Professor Suparna, Professor Krishna, the Fio, and Professor Sarva Mangala. So this clearly shows that the organizers have taken a lot of pain to organize it, to plan it. So thank you very much, everyone. Atul spoke on his experience, what he's seen, the River Rhine in the Germany. I was not knowing that. I thought maybe we are very dirty people in this country and our Jamna or Ganga are very dirty. But to listen to the strategy that was employed on the advice of one of the social scientists, that those who are using water in the uphill, and they should take water only from the downstream. So that paid back. Today, if you go to Europe, happen to visit Germany, you will find the Rhine is one of the cleanest river of the Europe. So this is what, as I assume, that what this seminar is, that the contaminants coming from pharmaceutical industry or from personal care, that would mean whatever industry is where we are using the chemicals, the process of contamination of water is going to be there. So we we are here concerned with we are in the Himalaya region. One thing is that we treat the water, recycle the water, as has been said, given the example of Singapore, that there the water, recycled water is consumed. And we also need to, time may come when such a situation comes. But at this time, as a student of biology and student of forest science, I would say that we can use tree crop animal system. I don't think the Himalayas are meant for agriculture. Himalayas are meant for growing of trees. So nature gave us forests. In the forest, you have the tall trees, you have the small trees, the bushes, the ground floor. And in agriculture, Himalayan agriculture, one has to copy tree crop system that on the riser you have the tall trees, then small trees, then economic bushes, and the ground floor economic plants. So that this type of a system can become both economical and also because trees are the greatest, I would say, the living organisms which can help to conserve the water. So not only conserve, purify the water. So in that situation, uh, uh, this type of it, because in the hills there is a terraced agriculture. We don't have the vast stretches of fields where agriculture can be cultivated. We should not play with the nature. We should do what the nature wants it. So now my second concern is about the School of Agriculture. Well, we are in the third year of our BSc Agriculture program, and it is named after the great son of India who gave us food. Once at International Union Forestry Research Organization World Congress, I was made to speak. I was made to introduce Dr. Swaminathan. What did I say? I said Mahatma Gandhi gave us freedom, and here is a gentleman who gave us food. Otherwise, when Churchill left India and out in 1947, he was saying that time is not far, that India will be back to us with a begging bowl. But then the Indian scientists did the wonderful thing, and today we are not only self-sufficient, we have 3 years of food reserve, and not only this, we also created a scene where other countries like us, which were in the developing phase, they copied us, they aped us, that system, how agriculture can be more economical, more productive, and can assure and this was the only way to get rid of the slavery. At Shoolini University is a small private university, neat and clean, located in the Himalayas, and we thought that its visit to this campus, one should think that one is in Scotland or in Sweden, and it will be a beautiful in the scenic system in the Himalayas, like any other institution where generally the Indian scenarios are dirty. We do not allow the student to throw papers, and we have put so many test weights, unimaginable, and they are made of the local material, the bamboo. They're not expensive, so that we can afford 1,000 bamboo baskets in the campus, which is making us neat and clean. So when we are doing something, we also to ensure that we give the facilities, create the conditions also for that. Our School of Agriculture, Dr. Negi himself is a great economist, and Dr. Gupta is an entomologist, and a host of other people are also subject matter experts. And since I have been associated with the Agriculture University in Himachal Pradesh as its vice chancellor, later as a scientific advisor to the government, I'm quite conversant with the system because as a professor of forestry also. Why should we use fertilizer in the hills? We should not. We should use the land use system. We should be more productive per unit area. That can only be the way that if we copy the nature. Shoolini University started as a research-based university. Today, I'm very proud to stand and acquaint the students, the friends outside from outside the country and others, that in the last, we are 11 years old in this period. Our citational data is rubbing shoulders with the global standards, but we are almost double than the India's the top universities. It is the effort and persuasion of the administration or the pledge, collective pledge by the students, teachers, scholars, everyone, that we will do research in areas which are concerned with the Himalayas, whether it's the climate change, the water conservation, all those issues are taken into account, or even the pharmaceutical products, whatever it is, that should match with our environment. And students in return, teachers in return should prepare such paper in the world's best journal. Maybe the 10% most cited journals, or if possible, in 1% cited, most cited journal. I'm very happy to acquaint the people that here we have excelled. Today, we are best in the world with 38% of our such papers appearing in 10% level or 8% in the 1% level, whereas we are ahead in comparison with the global standards also. So this is our journey, and we would like to, with other parameters, stand at par with global standards. So my advice to my colleagues is, our agriculture has not to be what you have studied in the plains. You should open your eyes, keep vigilant, and do things which can be adopted in the hills as per the topography. So I assure the organizers of this seminar that pollution is a part of agriculture, and if we do not use fertilizer in the hills, then we have to look for alternative means. That productivity cannot be sacrificed to anything. So with these words, I'm thankful to the speakers from outside the country, within the country, from the School of Agriculture. So they are doing an excellent job, and also the students. Many times students get impatient. This is of course the general thing. Students, they become impatient that the recognition of the college has not taken place. But ICR does in the fourth year. They will not come for the third year for us. The rule is a rule, it is for everyone. This is just a caution to the student, because in the fourth year, after the fourth year, they do it. So it will also be done for us. So thank you everyone. Do your best. Shine like other schools of the university. God help you. And I pray for the success of this seminar. Thank you very much.
Thank you very much, sir. Thank you so much for your kind words. Dr. Santanu, please.
Okay, thank you, sir. Thank you, sir, for your nice remark and so many good suggestions and very didactic informations. And now I would like to ask my project collaborator, Dr. Binoy Sharkar from Lancaster University, UK, to briefly introduce the project and to say to discuss about the purpose of the meeting. Please, Dr. Sharkar.
Shantanu, can you please confirm if you can see my screen?
Yes, it's full.
Okay. Yeah. Thank you, Shantanu. Thank you, everyone, for attending this event. My name is Binoy Sarkar. I am a lecturer at Lancaster Environment Center at Lancaster University, and I am the principal investigator for the small project that Lancaster University and Shoolini are doing together under the Global Challenge Research Funding Scheme, funded by United Kingdom Research and Innovation. So I extend my very warm welcome to each and everyone who are currently with us, especially the Chancellor, Professor Phem Kumar Khosla, the Vice Chancellor, Professor Atul Khosla, the Registrar, Professor Sunil Puri, the Dean of Research, Professor Kulakshetra, Dean of Agriculture, Professor Negi, all our respected invited speakers, and all the attendees, and of course my colleagues who are at Lancaster, from our department, and also the colleagues at Shoolini with whom now currently I am working. So thank you everyone. So I will very briefly give you a glimpse of our university where we are located. So here is the map of United Kingdom. If you see, most of you are aware where London is. So we are far north from London. So here is Manchester. This is our commuting airport, and we are here, Lancaster, about an hour drive from the Manchester airport. And this is an aerial view of our campus. And these different flags, they actually are the different colleges, represent different colleges of our university. And this is the main gate of our university. And this is the department. This is the single largest department of Lancaster University, which is the Lancaster Environment Center. And at a glance, our university is doing not too bad. In the UK league tables, we have 3 different league tables. In these league tables, we are 10th or 11th position, according to the latest evaluation outcome. And in teaching, we are gold. We are holding a gold evaluation outcome right now, and 83% of our research are internationally excellent or world leading. And in terms of student satisfaction, we are doing very well. We are actually placed 6th, number 6th in the entire country, and 83% of our students are satisfied with our overall delivery of teaching and research. And according to the world ranking, Lancaster is 132nd according to the QS World University Ranking, and 136th according to the Times Higher Education World University Ranking. So coming to the main business, we are doing a very short and brief scoping project here under the internal funding scheme of Lancaster University, and the money comes from the UKRI. So we thought the purpose of this type of small scoping projects are to build a team of like-minded people, like-minded researchers. So when I say like-minded people, it's not only the researchers. And our Vice Chancellor, in his talk, he was spot on that science alone cannot solve a problem. We need people from various disciplines, including finance, including social sciences. So through this scoping project, we want to build a team. We want to build a team of people, team of various science disciplines, as well as social scientists, as well as finance people, and non-academic people as well, different stakeholders, starting from the local government people, NGOs, etc. So this region we have selected because of the vicinity to the university, Shoolini University, and it is very important regions in the Himalayan region, because we know that Himalaya is the hotspot of biodiversity, and the environmental degradation problem is a massive problem there. So this rapid industrialization happened at this Badi, Bautiwala and Nalagarh region as well. And industrial hub has been established there due to government subsidized industrial packages and very good connectivity, transportation connectivity in the regions. And as Vice Chancellor has already mentioned, that it is the pharmacy of, it is called the pharmacy of India. So there means lots of pharmaceutical industries around that region. And there are about 230 villages and a huge cluster of various industries. And we thought, how about knowing the current status of origin and dissipation of pharmaceutical and personal care products in the water and in the terrestrial ecosystems as well in that region. And then whether we can develop and implement a data-informed research and technology development and assessment, as Vice Chancellor mentioned, whether we can treat the wastewater to a level that it can be drunk. And most importantly, the outreach, engagement, and education activities. Because one of the key components of the Global Challenge Research Funding Scheme is that we should improve the livelihood of people. We should improve the social and economic status of the inhabitants living in the region, in the target region of any particular project. So this is our research team. I am not spending too much time on this. Professor Kar Sample, he is the co-principal investigator from Lancaster University, and he sent me his apologies today. He was not able to attend because of some other commitment. And from Shoolini, we have Dr. Mukherjee and our three brilliant research people. So in the first phase of our project, we undertook a survey, very small survey, involving the inhabitants. So here we go. We actually emphasized the social aspects and economic aspects of this issue, pharmaceutical and personal care products contamination issue in the region. So this was in our mind, of course, and analysis of water samples. So this is our evidence-based research. So we collected samples, we analyzed them, and we also in the preparation of a risk map of this region due to these contaminants. And of course, we are having this networking event. And I should also say that the purpose of this networking event is to brainstorm, is to bring in new ideas from you, from attendees today, because we have dedicated discussion segments in this event today. So we want your inputs, we want discussion points from you, we want your feedback. And some of you, according to your expertise, possibly can join us in our endeavor to build a bigger project for the future so that we can apply to this GCRF, UKRI, or any other larger funding schemes to get funding and to try solve some of these issues that this region has. So we have selected the BBN region for this small seed project, but later on we can expand it. We can go to the other states in that region, and we can try to solve some of these problems. So thank you very much again for joining. Now the structure of today's program. So we will move to the project descriptions, like what we have done so far and what results we have found. So those will be presented by three of our excellent researchers in this project. So I will hand over first to Himanshu, and then to Arohi, and then, Himanshu, then Rajiv, and then Arohi to take us through some of our results. So Himanshu, can you please share your screen and start?
Thank you, Dr. Binoy. Hello, everyone. Once again, I welcome you all in this virtual networking event. My name is Himanshu Pandey, and I have completed my master's in environmental sciences. And currently, I'm working as a junior research fellow on this project in Shoolini University. So for our study of pharmaceutical and personal care products, we have chosen Badi,
Himanshu, sorry to interrupt. I cannot yet see your slides.
Okay, sorry, sir. So can you confirm it now?
Yes, please make it full screen.
Sorry for interruption. So for our study of pharmaceutical and personal care product, we have chosen Baddi, Barutiwal and Nalagarh industrial complex in the northwestern Himalaya region. It is situated in the periphery of Solan district of Himachal Pradesh. In a total area of 318 kilometers square. So as you can see in the image, from the western and the east side, it is bordered by Shivalik Hills and low hills. And from the north and south, it lies between Punjab and Haryana. So for all of our delegates from international community, so here's a map of India, and this is our national capital, Delhi. And here is the Himachal Pradesh, where this BBN region is situated, somewhere around here. Now, why this BBN area is so important? As we all know that lots of industries are situated in the BBN region, Baddi, Barutiwala and Nalagarh region, especially the pharmaceutical and the personal care product industries. So after receiving special industrial package from Government of India, this region has seen tremendous growth in the form of industrialization, which has led to various kinds of pollution. In the region, water pollution is of great concern, and in our study also we have tried to research on the water quality. Because of the poor water quality and the degradation of water, these have direct and indirect impact on the human and animals, which has led to like skin allergies, cancer, and many other congenital disease and disorders. In case of animals also, because of the usual drinking of water, there are reportedly various numbers of livestock death. And then all of this water which flow across the BBN region finally flows to Punjab state, where most of the economy is based on agricultural activity, and they frequently use this water. So that's why the BBN region is of such high importance. On your right side in the screen, you can see this image was taken from Google Earth. So you can see the color of water here is as black. It is taken from the Barotiwal region, where most of the personal care product industries are situated. Now in this image, which is from Nalagarh side, you can see the color of water has drastically changed, and it has changed to red color. In your left side, this is a battery factory, Ukaya factory, and while we were on the sampling physically, we were on the field, we observed that the color of this river is actually red in color. Now, so many people have to use the river to move from one place to another, or for their livestock. So it is also causing them skin problems, or their, as reported earlier also, the death of their livestock. Now, before I move further into the hydrology of the Solan district, I want to discuss very briefly about what a hydrological map basically is. So it is any kind of any chart or map which discuss about the hydrological feature of any region, which may include rivers, stream, or any other water bodies such as canals. So for this, for developing a hydrological map, so in this study we have used an ArcMap 10.3 version. So it basically used digital elevation model to calculate the flow accumulation and the flow direction. Based on these values, they create a stream order, and based on the order of the stream, like higher order, which signify a river, and if it is low in order, which signify any tributaries or any canals. So in this image, you can see a color gradient, which is basically a digital elevation model. And this digital elevation model was taken from Bhuvan database, which was developed by National Remote Sensing Center of Indian Space and Research Organization. So this is a user interface from ArcMap. So on one side, you can see all those database or all those tool set where you can search for like hydrology or any spatial analysis. In your right side, we have all those our digital elevation and the values for flow accumulation and flow direction. Now, the hydrological map of Solan district. So this is our India. So in the red box depicts here Himachal Pradesh, where lies the Solan district. Inside this Solan district, in the periphery of this region, there is Baddi, Barotiwal and Nalagarh region. Now, if you see here in this larger map, you can see there are lots of water bodies present in the area, which make it an ideal place for any industry to set up, because they frequently need water as a coolant and to discharge their effluent in the river water. Now, this all icon depicts the industrial zone. This is the Nalagarh industrial zone, this is Baddi industrial zone, and this is Barotiwal industrial zone. All these structure are actually rivers, and this red one and the sides are tributaries. Now to our sampling points. So prior going to the field for sampling, we have taken help of Google Map to identify primary sampling points. So for our research, we have taken Sirsa as our main focus. If you can see the pointer, so this is actually Sirsa River, and all these are the tributaries or canals. However, most of this portion is actually dried up. So we try to collect water sample from as much tributaries and canals we can actually collect samples from. Now, other than the surface water samples, we have also taken some of the groundwater sample, which is usually taken by villagers and the population for their drinking and other purposes. So in total, if you see here, we have taken actually we have taken 74 water sample, out of which 66 are total surface water sample and 8 are groundwater sample. Now, there are also some sites outside of the map, if you can see here. So these are actually we have taken them as a control, so that after analyzing we can compare it with the actual water sample which lies inside the BVN region. And apart from all these, we have also taken 10 BOD samples. Now, for our next component, I want to introduce Mr. Rajiv.
Thank you, Himanshu. Greetings to all. Now I will introduce you all to the public survey component of our research project. Myself, Rajiv Kumar Rana. I have done my master's in agriculture economics and farm management from Assam Agriculture University, and currently I'm working as a junior research fellow in this research project. Now we will start with the public survey component. First, we have the objectives of our public survey. So in our public survey objectives, we are intending to cover at least 10 villages and 2 urban areas of our study area. Our first objective is to get a demographic and socioeconomic profile of the sample population, which would help us in the current study and also as act as a valuable asset in the future studies in the study area. Our second objective is to get the level of environmental pollution awareness and ecological behavior of this study area population. In terms of third objective, we have the consumption pattern of pharmaceutical and personal care products, and we also lay an emphasis on the frequency of use and method of waste disposal generated from pharmaceutical and personal care products in this study area. Lastly, our fourth objective deals with the views and opinions of the respondents on the effects of environmental pollution on public health and their livelihood. Moving on to next slide. This is the methodology that we followed in our public survey. So the entire public survey exercise is based on non-probabilistic sampling technique. The reason behind it is that in this pandemic situation, it is very difficult to follow the probabilistic sampling techniques. In terms for selection of villages, we choose purposive sampling. The rationale behind this purposive sampling is that most of our village site that we have selected and selection of village has been done with keeping in mind the proximity of the water sample taken from the river Sirsa and the proximity of villages with the industrial complexes. Moving on to the final selection of people. In final selection of respondents, we chose a mix of quota and snowball sampling. The intended targeted sample that we kept for this whole public survey exercise is around 120 to 150, and it is an ongoing public survey exercises. Till now, in the first phase, we have collected around 35 samples. Moving on to the section 1 of our public survey. In this, I'll mention the demographic description of the sample population. So first, demographic descriptor. The first two parameters that we have are the age groups and the monthly income of the family. So in terms of age group, you can see that we have tried our level best to get an equal participation from all age groups. In terms of participation from younger age group, from 20 years old to 40 years old, you see that we have around quarter of population from each age group. In terms of population, in terms of participation, overwhelming participation from young age group generation, the reason behind the overwhelming participation is the reason that they are actively involved in society and also occupy position in the local panchayati raj and local administration. In terms of monthly income of this family, you can see on your right hand side that the monthly income of the family, in terms of the very low income, less than 8,250, this mark of family income has been selected based on the minimum wage rate that has been decided by the government of India. So you can see that overwhelming 72% of the population lies above the middle income and upper middle income and high income group. This tells you about the economic progress of the area and the study area in terms and in comparison to the general economic condition of the state and even India as a whole. Moving on to next set of demographic descriptor. In this set, we have two parameters. One is occupational status and the other one is educational status. In terms of occupational status, you see that there is a huge percentage of people who are self-employed in this region, followed by government employees, which are 22%. Despite having self-employment and government employment, we still see that a huge portion of 18% of the people are still following agriculture in either subsistence or in commercial level. Shockingly, if you see in the gray area of the pie chart, you will see that only 8% of the local population is involved in private sector in spite of having huge industrialization in the region. And with the number of unemployed people in the area comes about to 17%. Now moving on to the educational status, you'll see that 51% of the population involving primary and higher secondary groups. So more than half of the population have attended only till 12th standard. In the younger age group, we have graduates and postgraduates, which comprises to about 43% of the sample population. These all graduates and postgraduate fall into the younger generation group. In terms of illiteracy, we have only a nominal rate of illiteracy in our study area, which is around 3%, which is compatible with the high literacy prevalent in the state of Himachal Pradesh. Moving on to our section number 2, which deals with the environmental pollution awareness and perception. So in this, we will see what are the people's perception of population severity and its sources. On the left-hand side, you will see the perceived major sources of environmental pollution. In terms of major sources, you will see that industrial units comprises about 96% of the respondents said that industrial units are the major sources of population, and even 100% of the responded that the transportation is the major source of environmental pollution. Shockingly, 62% of the responded that households are also a source of major source of environmental pollution. Most of this pollution is contributed in the manner of solid waste. 21% of the respondents said that mining is also a source of environmental pollution. But in contrast, you see only 3% of the people think that construction contributes to environmental degradation, which is very shocking if you see that most of the people think that quarter of the people around think that mining is a source of environmental degradation, but the illegal mining is actually fed by the amount of construction that is done in the area. So this is a very contrasting outcome. In terms of perceived population severity in surveyed villages, you will see that in one of the villages like Kheda, you will see more level of water pollution is reported by the people instead of soil and land pollution. You will see an increasing trend of soil and land pollution as you move from village Kheda to New Nalagarh, which is an urban area. This is due to the reason that Kheda and most of these villages are located near to the river Sirsa or the industrial complexes. As you move from the villages to urban area, the reporting of soil and land pollution in form of solid waste disposal is high. Moving on to the sources of information and awareness. After seeing the severity of population in the area, we were intrigued to know what kind of communication channel and sources of information our study area population use. So in terms of age group, you will see that from the bracket 20 to 30, moving on to 31 to 40 and 41 to 50, you will see that in all of these age categories, you will see an overwhelming penetration of social media. In age group 20 to 30, you will see that 100% of the people use social media. So in terms of penetration, we see that social media has penetrated all the age groups. Next, moving on to the brown bar, which represents the newspaper usage. So you'll see that as you will move from the younger generation to older generation, the usage of newspaper as a source of information increases. In terms of reliable source of communication in the area, you will see that TV, which is represented by the gray bars, in most of the age groups, more than 60% of the people across all the age groups still rely on TV as their source of information. In terms of local interaction and gossip as their source of information, you will see the green bar represents an increasing trend as you move from the younger to older generation. There is an also very interesting observation in terms of social media usage and using local interaction as your source of information. You will see that more a person uses the social media, less social behavior he has. So you will see a contrasting effect in terms of 100% usage in social media in younger generation, but only 37 to 46 to 88% usage of local interaction and gossip as a source of information. Moving on to our section number 3, which is concerned with the use and consumption pattern of pharmaceutical and personal care products. In terms of use and disposal of PPCPs, almost all of our respondents, around 97%, reported that they are using common personal care products and pharmaceutical drugs. In terms of frequency of use of PPCP in the respondents, most of the people use daily the common personal care products and occasionally the pharmaceutical drugs, except the respondents who are suffering from some kind of chronic illnesses. In terms of waste disposal behavior, the respondent responded a myriad of disposal behavior, ranging from disposing and throwing the waste in designated bin to burning, to burying, or even throwing in open. Most of the participants, an overwhelming 82%, admitted to purchasing medicine without doctor's prescription. Moving on to our last section of effects of environmental pollution on public health and livelihood of the people. So in terms of public health, the people have reported various diseases due to air and water pollution. In air pollution, we have asthma and silicosis. In this category, silicosis is the disease which is caused by the cement dust generated by cement producing industries. Similarly, water pollution led to various cases of stomach and gastrointestinal infection. Other chronic diseases which are reported in high number and are rampant after the boom in industrialization are cancer, skin allergy, heart diseases, and other cardiovascular diseases. In terms of effect on livelihood, you can see that in agriculture, due to polluted water or effluent released from the industrial areas, there is high chances of crop failure if the crop gets in touch with the polluted water. In the decade or so in which the industrialization has increased due to air and water pollution, there is an decreasing trend and reduction in yields of crop, which has been observed in all those decades by the agriculturists. In terms of problem witnessed in livestock, due to coming in contact with this industrial effluents or even river water from Sirsa River, which is polluted by these effluents, that it causes various kind of diseases in livestock, and in some of the cases it has been reported that the direct consumption of this water led to death of livestock. In terms of local groundwater level exploitation, there are two major reasons of this groundwater level exploitation. First is the amount of water that is used by these industrial complexes. And the second one is the illegal mining that is going on in Bati and Borotiwal area. So these are the effects of environmental pollution on the public health and livelihood of the people. By this, I conclude my component of this research project and hand over the presentation to Dr. Arohi Dikshit, who will explain you the sample analysis and the result part. Thank you, everyone.
Hello, everyone. Thank you, Rajiv. I am Arohi Dikshit, and I have completed my PhD from School of Environmental Sciences, Jawaharlal Nehru University. In this project, I am working as a research associate, and I'll be discussing the analytical part of this research project. Starting with the sample collection and field analysis. In total, 66 surface water samples were collected from Sirsa River, and the parameters were analyzed both in field as well as in laboratory. The samples which were parameters were analyzed in field are pH, total dissolved solids, dissolved oxygen. Samples were collected, brought to the lab, preserved as per the requirements of different parameters. And all the procedure was done according to the standard methods. Now coming to the laboratory analysis, we are focusing on some target PPCPs, pharmaceuticals and personal care products. For them, we filter the samples, and the PPCPs we are targeting here in this study are ciprofloxacin, norfloxacin, cetirizine, and citalopram. Now, why we choose these four analytes are because of their wide presence in Indian water system, and also in this area, a large number of factories, industries, they are producing these compounds. There are some other similar compounds present widely in Indian systems are also there, but due to short duration of the project, we are focusing on these. Now regarding this, today's presentation, we will be focusing on ciprofloxacin and norfloxacin only. Cetirizine and citalopram are still in the process of analysis. Now, before we proceed to the results, let's have a look on the points which are adding contamination to the river. Like when we visited the fields, there were in the long stretch of the river, there were at various points, it was receiving drains, effluents. There was a landfill in the vicinity of the river, which was adding its effluent from various smaller drains, various point and non-point sources. So these were the points we observed as the contamination points. And these are very much connected to our results also. It is also said that this river, where other than the rainfall, has the major source as the industrial effluent, which has almost lost its volume, and the major source left is industrial effluents only. We will further discuss these points while we will be discussing the results. Now coming to pH, the pH was observed to be alkaline in general. Around 95% of the samples were above 7. The TDS observed was greater than 500 milligram per liter in majority of the sample, approximately 25%. TDS ranged from 214 to 1150 milligram per liter. Also, dissolved oxygen values observed were also low at certain points. They were even below 1. All those points where we were receiving high TDS, low DO values, and very high BOD values, all these points were those where we were observed addition of some kind of drains. BOD in this study ranged from 3.6 to 230 milligram per liter, and certain points it was greater than 200, which was very high. Now, when we compared our results, so we found the studies of Sharma et al. 2019 and Hirojit et al. 2017, which is done in the Sirsa River only, the results were comparable. Now here we can see that we have marked those stretches which were receiving the drains, And in those areas, especially, we observed high ranges of TDS, high ranges for pH, and low values for dissolved oxygen. So in these regions, it was towards the Nalagarh region, and majority of the samples here in this region were showing very low DO values. And this was the reason. And also in this region, we observed high TDS values. This was the one which was receiving the drain. So now coming to this, so these were the points which I have marked here, S1, S11, S30, S34, and S41. And the one which is the complete stretch where majority of the industries are concentrated in the Nalagarh region. So this is the reason. Now coming to instrumentation for the analysis, we used a SPLC system, which is a Dionex USPLC Ultimate 3000 system connected to an auto sampler and a diode array detector. The column compartment was having a C18 analytical column. We used the mobile phase for this method, which comprises of 1% formic acid and acetonitrile in a ratio of 84:60. Now the samples were run at a flow rate of 1 milliliter per minute, and the wavelength which was set in this instrument was 274 nanometer. Now talking about quality control and quality assurance, so we observed a very good calibration values. So the values were 0.99 for both ciprofloxacin and norfloxacin. The retention time for ciprofloxacin was observed for 6.59 and norfloxacin it was 5.90. Now coming to limit of detection, for ciprofloxacin it was 9.2 and for norfloxacin it was 7.3. Whereas limit of quantification was 28.1 and 22.1 microgram per liter. Now coming to recovery, so for ciprofloxacin, they were observed in the range of 90s, and for norfloxacin, they were observed for range 80 to 890. Now coming to representative chromatograms. Now here we can see in the first figure, you can see it is a chromatogram for a standard of 500 microgram per liter, whereas in other figures, we have tried to mark the concentrations in the samples. So in sample 26, we can see a very good peak of norfloxacin has come up. Also in sample 30 and sample 68, we observed both presence of both the analyzed norfloxacin and ciprofloxacin. Now coming to the concentrations of ciprofloxacin and norfloxacin in the samples. Norfloxacin was found to be 1.5 to 277 microgram per liter, whereas ciprofloxacin was 2.4 to 126 microgram per liter. Now here we can see these are again those similar points where we observe addition of drains, either there were addition of drains or industrial effluent. Like S1, it was effluent discharge. S11, it was industrial drain. Like it was passing through the river and then adding its discharge. Now these parts, this was also a complete black sewage drain which was coming. So this was those point where drain was adding. This was again the similar points which were receiving non-point sources and various smaller drains which was adding the waste from nearby villages. Now coming to S34, this point was, these were the points where waste was adding from a sewage effluent treatment plant. Now in this area, it was adding the waste from a landfill. Okay, so a landfill was just in the vicinity of this river. So there was various smaller pathways going and adding its water. Now coming to this region, again, this was the region where majority of the industries are situated in this region when we are heading towards the Nalagarh region. So this was an industrial cluster zone. In all these points, like high concentrations of like in point S68, point S54, and S11, we observed high concentration for both ciprofloxacin as well as norfloxacin. So in general, we observe that whenever there is adding of drainage system or some effluent, there is high concentration. When we are heading towards Nalagarh region due to cluster zone, there is also presence of, in majority of the samples, we observed high concentration of PPCPs in this, all the samples. Now, when we compared our results, we observed that at similar concentration of ciprofloxacin, Sharma et al. 2019 have observed high health risk for both children and adults. So this was a point of concern and alarming bell for us. Now, these were all the points we have already discussed. Now, coming to future analysis. Although we have completed a majority of the points, but still a lot more to cover. This includes second sampling in the month of August, analysis of target analytes, citalopram and cetirizine, analysis of cations and anions, analysis of heavy metals, arsenic, mercury, cadmium, chromium, copper, iron, manganese, nickel, lead, and zinc, and determination of chemical oxygen demand. So majority of the things are either completed or in the process of completion, and we are about to compile our results. Now coming to the summary of the work. Study area and hydrological maps are prepared using ArcMap 10.3. The detailed background information and active network built during public survey will help in further future research studies. It will also be interesting to see the correlation between the perceived level of environmental pollution by the local population and the level of pollutants actually found in the water samples of the area. Now, coming to pH of the collected samples is found to be alkaline in range, ranging from 6.1 to 9.2. High TDS, low DO, and high BOD values were observed at all those points which are receiving effluents, either municipal or from industrials, or those samples which are present in the vicinity of the landfill site or the waste CETP, that is the common effluent treatment plant. And also high concentrations, greater than 100 microgram per liter of ciprofloxacin and norfloxacin both were observed in those surface water samples. Now, at last, I would like to thank Lancaster University, Lancaster Environment Center, Global Challenges Research Fund for providing the funding and all the support. I would also like to thank Shoolini University for giving us the for helping us in analytical work and everything. I would also like to extend my thanks to everyone who is directly or indirectly related with this project, who is helped in the completion of the objectives. So I would like to thank Dr. Anil Kumar, Dr. Renu Negi, Dr. Hirojit, Mr. Umesh Kumar, Mr. Barpreet Singh, and Mr. Kamlesh Pandey. Thank you very much and Dr. Pratima as well for, thank you so much everyone for providing help and support for completion of the objectives of the project. Thank you.
Yes. So yeah, thank you very much, Himanshu, and then Rajiv, and then Arohi for giving overview of the activities that we have been doing in the last 3-4 months. And I should mention here that this project is a short duration scoping project. Total official duration for this project is only 4 months. And you can imagine that whatever activities have been completed so far, we have done it within this lockdown period, very challenging pandemic period. And I must mention here that the level of support from the university, from Shoolini, that we have received is exemplary. And we always go for doing research at big name institutes, IITs, and very big universities. But the level of ground support and administrative support that we have received for doing these activities at Shoolini, I would say is just exemplary. And thank you very much for that. Now, we are running awfully behind our schedule. But still, I think one brief discussion session now, maybe about 10 minutes, to give some feedback to these very hard-working our researchers. They are the core for our team, and they have done all the groundworks. So your feedback would be very much valuable to them. So I open next 10 minutes or so to receive your feedback, your queries, and your question, please. So you can unmute yourself and ask your question, and one of our researchers or either Dr. Shantanu or I will attempt to answer that. Thank you.
Hello.
Yes, please.
I'm Shravan Acharya. It's very interesting, work that you are doing. And incidentally, I happened to be there in Baddi Batori Tiwala in 2005 from SEPT Ahmedabad when we were doing a physical planning exercise for the industrial estate. So I've thought this is a very interesting project, and also many other hill states are also having similar issues. I was just a few suggestions I want to make. One is regarding your socioeconomic survey, the sample and the analysis that you have done. Is it based on the 35 respondents that you have done the socioeconomic analysis?
Yes, sir. At this stage, we have only 35
Yeah, then
responses.
my suggestion is, even if it is at this stage, you should not use the percentage. That is very, very, it doesn't give you a proper information. Unless you have a larger sample, then only you can convert it to percentage. Otherwise, just like the sample of the physical water quality that has been done, you can tell the absolute numbers. So that is one thing.
Yes, sir.
The other thing which I would like to suggest, because I am basically a planner, many of these exercises, you need to do it spatially. And anyway, you are using ARC, map.
Yes.
I think if you can superimpose some of your, socioeconomic analysis and also your, the water quality analysis spatially, by creating some layers, socioeconomic layers and the physical layers and the drainage system, then it will be useful. In this context, I would like to highlight two things. One, since you already have some statistical information based on sensors or any other information, it is very important to map the density. When I say density, it is not only about the population, but also of the many of the physical units which has been built, right? That is one thing. And the other thing which I think you have missed out is you are only talking about the villagers. But the industrial estates also has a lot of migrant laborers, industrial workers and all. And they are the one of the most vulnerable people in terms of this exposure to some of these industrial activities, not only the agriculturists and all. So I think if you can include those, I think then your study will be more comprehensive. I had one question regarding the water quality, but anyway, she said that it will be again, because I don't know what time, when was the sample taken, which month?
Arohi?
Yes, sir. Sir, in the
Because the water quality will vary depending upon the season, right? So
yes.
Yes, sir. So next it will be in the month of August.
Okay. Yeah, that's all. Thank you. So I think the water quality sample has to be increased.
Yes.
To get a annual perspective. Thank
Yes.
you.
No, thank you
sir.
very much, Dr. Sawan. These feedbacks are extremely valuable, and some of these aspects it is in our mind, which we are already doing within this 4 months projects, and some are will be done when we develop a new project. So thank you very much for your kind inputs. Any other questions? So I think there was one question in the chat from Professor Gurjot Kaur. So about dissolved pharmaceuticals. So Arohi, do you want to make a comment on that?
Yes, ma'am. We are focusing on dissolved pharmaceuticals only. So we have observed, we have analyzed dissolved one right now.
Yes. So yeah, in the sample preparation, I think Arohi has filtered those samples before putting them into the machine, and the sediments we haven't analyzed yet. That is another critical aspect that we should focus as well.
Yes.
Yeah, actually, may I say something?
Yes, please.
Yes, please.
Yeah. Okay, great. Yeah, I think first I would say I would congratulate I think the Shoolini University and especially the researchers that are involved in the project, and it is really very what do you call, like very surprising, and to get a lot of information and data within no time. That is 4 months is nothing actually. Okay, to see such a kind of a progress within 4 months is really, I should really appreciate and congratulate you on it. And having said that, the thing is, like, if I have not missed, actually, what is the next step that you have thought about? For me, I would think like, taking up some of the blood samples, because you have clearly found out that more than 90% of the inhabitants are some or other way exposed to these pharmaceutical products. So, I mean, it is also now important to see these levels inside the bodies, collecting some of the blood samples, which is very crucial and very critical. I know the sensitivities. We are also dealing with some of the, in a similar aspects on metal accumulation and metal exposure to the humans. So in the same lines, it would be very much interesting to frame out a clear-cut lining and to understand the incorporation. Now we are looking at the exposure, thinking about the values that are present in the water. Now, once we know they are exposed, then how much are they being incorporated? This would be a very valuable and highly, useful result that can take you to the next level to my expectations, to increase the social awareness, social impact, and also to take any kind of immediate decisions by the local authorities and so on. I think this will bring us more focus from environmental to the next class of taking decisions at the higher level. So this is my first suggestion.
Hi, Gopala.
Please.
Hi. Can I make a comment to your comment?
Yes,
Yeah,
yes,
please,
of course.
please.
Please.
Yes, good job, please.
Because they are just looking at antibiotics right now, it does not really make sense to look at blood samples. They are better off looking at the skin, because if the skin is going to come into contact more than the blood at this, from sewage, right? Not blood. So, and they would be looking at bacteria, they would be looking at the changes in the skin, which will be very visible in these people, dry skin, and many tests are out there. If they are seeing this on the skin, because you have to understand, as a toxicologist, I know that it does not really seem like everything goes to the blood. There's a whole system that has to be looked at, which means that how does it go to the blood? From your gut, most probably. Even from skin, there will be not so much absorption into the blood. So they have a better chance. They're looking at antibiotics too. So better chance at success if they look at the skin.
Yeah, I mean, you see, I'm not basically a biologist, but my way of expressing is that, to look in once they are exposed, at the end point where maybe a blood or maybe a skin sample, whatsoever it is, but to know that how much is actually being impacted finally, maybe we are presuming that more than 90% of the inhabitants are actually exposed. But now, to look at how much is actually being there with the inhabitant is something that would be important.
That's a great idea. I mean, I work on, human toxicology, so I understand this. But I think one of the ways they can really look at this in an easy way is to go to the hospital make a collaboration with a doctor, a skin doctor, and just ask them what kind of people are coming in, what are they coming in with, because a lot will just clear up just like that. A lot of it is because of bacteria. Your healthy bacteria are dying. That is why your skin is all rashy, and there are other sorts of diseases coming in. If they would be looking at, for example, a beta blocker or something, I would think, okay, maybe it's going into the blood. But as an antibiotic, I would look here, and then maybe if they are seeing something, I would look at the gut microbiome.
No, absolutely. I agree with both of you. I think our kind of consensus point is that we look at the exposure pathway in detail, and that is extremely critical in any contaminants exposure and impact assessment. And yes, our Vice Chancellor at the very beginning said that this research needs to be disciplinary, multiple stakeholders should be involved. And yes, I cannot agree more with you that we need to work with hospitals, the local hospitals and the doctors. And yes, very, very useful and very valuable points are coming up from this discussion. So thank you. Thank you very much.
Actually,
yes, Rajiv, please.
Sir. Sir, both the comment made by our honorable guest, Dr. Gurjot Kaur and Dr. Gopal Kumar Darba. So we have a measure in our public survey to indirectly measure both of these contingency. In terms of blood samples, you are trying to find out what kind of pollutants are there. So in terms of skin allergy also. So what we are doing in our public survey in the last part of effect on public health, we are trying to get the family history of diseases in the area. For example, in your family, if somebody is infected from a skin allergy or cardiovascular diseases or cancer, so in that history, we can see that what is the proximity of those families to the polluted water, or in terms of other pollutants, what is the proximity? So there is an indirect measure. For example, we can't analyze at this stage the amount of pollutants in blood samples, or even getting samples from hospital, because I have talked in our public survey with various stakeholders, including doctors. So they are not so willing to disclose their patient's history. But in terms of indirectly finding about the history of the family in public survey, that is easy. So it covers both point of Dr. Gurjot and Dr. Gopala. Thank you for your comments, sir, ma'am.
Yeah. No, thanks, Rajiv. Yes, I agree. And this is a clear, perhaps a work package in our future project as well, because within the current situation, we are limited because the project duration and the funding. But the aim of this project, this scoping project, was to understand these key problems like this, So we went there to do this. Then we identified this very critical issue that we need to go and try to, understand more straight away. So this is very, very nice.
So may I add something, if I may?
Of course, please.
Yeah. So I feel that, of course, as Mr. Binoy Sarkar said, that, it's very difficult to go and, and looking at the current pandemic also, like it's very, very difficult to just go and, look into details, because to be honest, when we go and to search the government data, they do not want to respond to all these things, of course. And we have to keep everything in mind so as to make the project functional, so that it does not waver off, or maybe just does not get swayed by the, whatever is happening in the world right now. So of course, keeping that in mind, and viewing it from the point of view from the larger aspect, I feel that, waterborne diseases, whatever it is, it's a rash or whatever it is, it's something which I would say that, which is coming, and even the doctors recognize the fact, and it can occur based on, even if it's not genetic, right? So for example, if a person is having some sort of keratosis pilaris, or maybe that person might have some sort of autoimmune or something like that, that's something where doctors can recognize the fact, and waterborne diseases are basically characterized in that way, where we don't have to fall very deep into this particular study. We're involving a lot of doctors inside. But the thing is that we can get a clear survey of that thing. Whatever is waterborne, that must be taken into consideration so that the project is also not hindered in a way.
Yes. Yeah. No, thank you, Dr. Bandana. This was another very useful and valuable comments. So I think we are tight with time, and we have invited speakers, and they have other commitments as well. So we have actually another open discussion session like this at the end. So I would request all of you to stay until the end and participate in further discussions. I sincerely apologize that we started late and then we came to the real program a little bit delayed. I sincerely apologize for that. But now to accommodate our invited speakers, we need to move on. So Shantanu, how we do it? Because as far as I know, Professor Mukherjee has some other commitment. Shall we start straight away with her talk, maybe?
Yes, may I ask Professor Mukherjee, are you here, madam?
Yes, I'm here.
Okay, so now I will ask Arohi to introduce her, and then madam, just you please start your presentation after.
Sure.
Arohi, please introduce Professor Mukherjee from IIT Mumbai.
Yes, sir. So, hello everyone. I welcome you all to the second session of today's networking event. I'm very excited while I'm starting the session, as today we have presentations and discussions from some highly renowned researchers all over the world. Now, before we proceed to the session and start the presentations, I would like to mention the time. Every presentation will be of 15 minutes and there will be a reminder bell 2 minutes before. Now, proceeding to the session. First presentation we have is from Professor Suparna Mukherjee. Professor Mukherjee is currently a faculty in IIT Bombay in the Department of Environmental Science and Engineering. She completed her PhD in Environmental Engineering from the University of Michigan, USA. She has also received the National Women's Bioscientist Award for her outstanding contribution in basic and applied research in the areas of biosciences. She is an associate editor in some highly renowned journals and is a member of various national and international societies. She has given her outstanding contribution in the research areas related to biotransformation and toxicity evaluation of complex organic pollutants, characterization and treatment of grey water use, monitoring and removal of micropollutants from water, and physicochemical and biological treatment processes. This has also led to publication of her work in some topmost journals of the area. Now, I would like to welcome Professor Mukherjee for her presentation.
Thank you, Aruhi. Can I share the screen?
Yes.
Yes, madam, please.
The screen is all yours.
Yeah. So thank you for inviting me today. And I'm very happy to see that you are also working in the area of monitoring pharmaceuticals in the rivers. And the level of concentrations you have found, I was noting, are quite high. In fact, I think sometimes higher than what we found in sewage. So that was interesting. But anyway, so we started working in this area about my first student started working in this area, I think, recently finished last year. So almost 5 years back that we started working in this area. So, yeah. So how does pharmaceuticals end up entering the river? I think Arohi just gave a detailed account of how they enter either directly through sewage or through treated sewage. So even after it is treated, the removal may not be to such an extent that you get good removal. So eventually they may end up in the rivers. But I must say, I did not think the concentrations would be as high as you showed today. It may also come from the industries. So from industries, the industrial effluent is treated in CETPs, and from there, even after treatment, there may be residual pharmaceuticals which may enter the rivers. We also have other sources like animal farming, agriculture, which can pollute our rivers. And from there, eventually, when we use the river water in treatment plants and treat and supply to the households, we may find a situation that we have contaminated water being supplied. That is the biggest concern with which we need to view the problem. And the same problem can exist in groundwater also when we have groundwater contamination with pharmaceuticals. And the concern here is that even at low concentration, they can be harmful to us. So nanogram per liter to microgram per liter concentration is what we are looking at. And that too is not a good idea to be exposed to. So all over the world, we are looking at this problem that there is pharmaceuticals and personal care products which are found in the treated wastewater and in natural water bodies. This has been found for a range of different classes of pharmaceuticals. Some pharmaceuticals we find after treatment, their concentrations increase, like the concentration of carbamazepine, very commonly found to increase after treatment because of a conjugation and deconjugation phenomena that happens. And pretty much all rivers now have some degree of contamination with pharmaceutical, although measuring it may be tricky because of the low concentration. And the very, as I said, about 5 years back when I was looking, this image was a very remarkable image to me, that from the tap water, we may be getting water which is contaminated with very low levels of pharmaceuticals, and that can have an impact. So what impact am I talking about? So things like chronic toxic effect, and particularly because many of the pharmaceuticals have endocrine disrupting effect. So they can affect the hormones in the natural body. They can act as agonists, as antagonists. So they can enhance the response, or they can regulate the response and destroy natural hormonal activity and even cause destruction of enzymes. And through the EDC action, it can have a whole range of effects, right from metabolic disorders to attention deficit disorders to neurodevelopmental disorders and cancer. So given this type of a range of problems that can happen because of pharmaceuticals, we need to take note. And the adverse effect on aquatic life is already visible near sewage treatment plant outfalls. There is sex change in fish, reptiles, birds. So even at environmentally relevant concentrations, this is a concern. And antibiotics, of course, is more of a concern, because if we are releasing low levels of antibiotics to our water bodies, we are changing the microbiome there. So initially, we may having very few antibiotic resistant microbes, but once the antibiotics are there in the environment, we will have development of more and more antibiotic resistant microbes, because that the ones they are not will not survive, and the ones that survive will multiply, and they will pass on the genes to other microbes, and thus we increase the risk of diseases. So we may see a situation that disease is caused by drug-resistant microbes, and that may not be curable with the antibiotics we are used to using. And in fact, major rivers like Yamuna River, it has been shown that they are contaminated with antibiotics due to sewage treatment plant outfalls, hospital effluents, etc., which has been shown by Professor Ziauddin's group in IIT Delhi. So what about the wastewater treatment plants? Are they removing or not removing these antibiotics? I have put two different types here, the ASPs and the MBRs. And from published literature, we can see this is showing the level of different classes of antibiotics and the range of antibiotics present in the influent and effluent. So you see, for some, although there is removal, we see that there is a significant presence still after it is removed. You may have an order of magnitude decrease, but that level is still a concern. Whereas for others, we see in the effluent, the concentration increase, for example, in the group I. So this is the concern. And as I said, at the time we were starting, a few groups had already started monitoring and they had found presence of antibiotics in river water, like in the Yamuna River. And they have also found, for example, in Karnataka, they have found presence of various antibiotics from chloramphenicol to erythromycin to trimethoprim, etc. In our study, we were focusing on wastewater treatment plants in Western India. And here we were looking at the levels in the influent and effluent for a range of different pharmaceuticals that we selected based on a survey as to what was being prescribed. And we found that they were present in the influent and in the effluent in quite significant concentration. Now I'll try to bring out some of the challenges in quantification of pharmaceutical. So quantification itself is a challenge because we are trying to measure low level of pharmaceuticals because they are not really present at very high level. And even when they are low, they are having an impact on our health. That is the concern. So we mostly filtered the samples and then did solid phase extraction and then measurement. And after the initial few measurements, we realized that the wastewater matrix was having a huge effect on our results. So this is how complex the sample treatment is for solid phase extraction. The key step is loading your sample and then eluting it and then concentrating. But you see, there are a lot of intermediate steps that has to be done right for you to get representative measurements. And what we found is a lot of optimization was needed to get and quantify the antimicrobials properly when we were using the HRLC-MSMS system. So we had to optimize columns, optimize mobile phase and the capillary voltage, fragmentar voltage, collision energy. And with all of this, we could get the measurements done. However, what initially really created problems is, in fact, I would say not initially, it is a problem that we all must be aware of. That is the problem of matrix effect in the HRLC-MS measurements. So this is the interference that is caused by the combined effect of all the things that is in your sample apart from your analyte. So while you are trying to quantify your analyte, all these other things in the matrix can have an impact on the detection, on the selectivity, repeatability, and the quantification of your samples. So several co-contaminants can affect the results. These include inorganic electrolytes that are present, organic molecules can affect the results, and even metabolites, etc., that are present in a sample can interfere with analysis when we are trying to analyze the pharmaceuticals. So this is a big concern that when we do solid phase extraction that also have, let's say, dissolved organic matter in it, and that also get extracted along with the pharmaceuticals. And then when we are measuring it in the HRLC-MS interface, it is affecting the measurement itself. So what we are thinking we are measuring quantitatively, maybe our measurements are not quantitative. That is the concern. So things like ion suppression can affect the results that we are getting, particularly so for molecules with higher mass that suppress the signals of the smaller analytes like pharmaceuticals. So more polar analytes will be more susceptible to this ion suppression effect. So these are real concerns that we have. And presence of higher concentrations of non-volatile solutes can significantly affect the results that we get and can really mess up with the quantification that we are trying to do. So here I'm showing two different, so we tried both without using isotope level standards and with using isotope level standards as internal standards. So WISDM is without and ISDM is with. So even when we use ISDM method, you see the variability reported in the literature when you are trying to analyze different pharmaceuticals. This is showing the range of variability in recovery of pharmaceuticals from a wastewater matrix. So we see very large range, ranging from about 30% to close to above 100%, so close to 100. So what we tried is, we tried adding 0.1 milligram per liter of pure pharmaceuticals into wastewater, 10 ml of wastewater, and then we tried to recover and see what were the recovery. This is the work of my PhD student, Sanjeev Mahapatra. So what you can see is the recovery is affected by the water matrix. It varies from the influent wastewater versus effluent because they have different composition. You know, the treatment process changes the composition of the dissolved organic matter as treatment happens. And as a result, we see that the recoveries of the pharmaceutical changes in the process. Even when we do with ISDM, because ISDM is the way to avoid problems with recoveries, but we still find that that can cause some interferences in the process. However, when we spike it in dissolved, DI water, then there is no problem. Whether we use ISDM or without ISDM, there is absolutely no problem. We get good recoveries for all the pharmaceuticals. The problem comes when you have a wastewater matrix. The matrix effect itself affects the result. And this type of thing can also happen in a natural river water. I would like to mention, since you all are interested in that, natural river water also has humic substances in there. So that can also cause interferences. So what I show here is this is some sample where we spiked, we extracted the organic matter, fractionated it, and then we spiked different fractions of organic matter in the water and tried to look at the impact of recovery of various pharmaceuticals in the presence of this organic matter fraction. This is only one of the fraction, the hydrophobic fraction, where you see that without the ISDM, you have very low recoveries, whereas with ISDM, we get reasonably good recovery. However, that is dependent on the type of pharmaceutical. These are different wastewater samples collected from different wastewater treatment plant, influent and effluent. And now this is showing the impact of concentration factor. That is another thing. In the last analysis, I was showing you an effect of 10-fold concentration. But really, when we are measuring in wastewater, we need much more concentration, something of the order of 500,000, etc. So as your concentration factor changes, that is another thing that can impact the recovery values. So these are things to keep in mind when analyzing pharmaceuticals. I was telling you, we did some measurements in wastewater treatment plants. These are some of the results for different wastewater treatment plants that was found by Sanjeev Mahapatra. So in many cases, we found the concentrations were higher than that in the literature. Now, if you see our values, they're often higher, but if you note many of these values, for example, norfloxacin, it is lower than what you are finding in the river water, I think. So that was very surprising to me. So the next, we were looking at percentage removal in the treatment plant. So treatment plant removal ranged mostly between 40 to 100%. In some cases like carbamazepine, it was totally messed up because the influent is low and the effluent is high, because it is released in sewage in a conjugated form and deconjugation happens during the treatment. So basically you have removal due to volatilization, biotransformation and photolysis, but some may also get adsorbed onto the sludge. And as I said, in some cases you have major confusion because of the conjugation, deconjugation phenomena that happens. So even after removal, the concentration that remains is of concern because that can affect the ecotoxicity, that can affect health. So we then looked at removal of pharmaceuticals through various processes like photolysis. In fact, the organic matter, that is organic matter like humic matter or which is soluble organic matter, and also particulate organic matter can affect the removal of pharmaceuticals. So we have looked at phototransformation of pharmaceuticals like acetaminophen, and we found that it was not a complete degradation possibly, but transformation that was happening. And that transformation was affected by concentration of the humic acid and also the type of degradation. In presence of soluble organic matter, we found that humic acid was degraded in a first order mechanism, whereas when we had particulate organic matter, that is fine particulates, it was degraded through second order degradation pathway was seen. So we did some investigations of this nature. I'm just showing one example of this. And then that was through photolysis, and that was UV photolysis. And here we are looking at photocatalysis, where we have explored different photocatalysts like TiO2ZNO photocatalyst. And we were looking at the removal of pharmaceuticals through this in presence of this photocatalyst. This is a work done by another student, Gayatri Menon. She has also finished her PhD. And here we found very interesting results. So pharmaceuticals are removed even by photolysis, but we find that photolysis removal is only partial removal. It doesn't get fully degraded. But through photocatalytic removal, if we treat it for sufficient time in the exposure to light, in this system, actually, TiO2 alone would need UV for action. Whereas with the TiO2ZNO system, we could explore the visible light activity also. So that is why we were exploring this photocatalyst. And we found that acetaminophen can be degraded. And in fact, ammonium gets released initially. And then you have generation of nitrate. We measured these, and we also measured the TOC removal. We also looked at disappearance of the acetaminophen itself. So it looks like acetaminophen gets degraded. Very low concentration of some products get released. These are with very low concentration of the photocatalyst. We used as low as 10 milligram per liter of the photocatalyst, so very low concentration. And we were trying to remove 10 milligram per liter of acetaminophen, whereas most studies have used much higher photocatalyst concentration. We limited the concentration of photocatalyst, but we see that even with this, we can get good removal, both under UV and visible irradiation with the TiO2ZNO photocatalyst. So photocatalysis can give good removal of pharmaceuticals. However, photolysis alone will typically cause incomplete transformation. We found good removal with photocatalysis for a range of different pharmaceuticals. And we found that toxicity also could be reduced. In fact, in one study, we were looking at removal of endocrine disrupting substances like estradiol and ethinyl estradiol, where we found that the endocrine disrupting activity could be reduced after the photocatalytic treatment. All of this was Gayatri Menon's work. And then this is one snapshot of a work which was done in Professor Shoma Mukherjee's lab, where I was also co-guiding the student, Pooja Nag. And what she did is, she was developing sensors for monitoring pharmaceuticals. From my presentation and from your own experience, you would know how costly the measurement of pharmaceuticals are. So this is a low-cost, effective method is to develop biosensors. So Pooja was developing biosensors. In fact, this was a sensor using a Pseudomonas aeruginosa strain that we had isolated from oily sludge. And that Pseudomonas aeruginosa was sensitive to cephalosporins. So she used it in this optical fiber platform with gold nanoparticles, on which the Pseudomonas aeruginosa was immobilized. And with that, she could do quantitative determination of third generation cephalosporins. The LOD was 10 microgram per liter. So Pooja has also finished her PhD. So in summary, I would like to highlight that solid phase extraction followed by LC-MS-MS analysis is widely recommended, but we need to work on the method development and we need to look at the interfering factors that may affect our result. And when analyzing the pharmaceuticals in wastewater, we have to be very, very aware of the impact of co-contaminants that are present on the recovery values that we get. And ISDM is a better method to use than others. And the removal of pharmaceuticals can be caused by various mechanisms in treatment plants, which includes adsorption, biotransformation, and photodegradation. But the removal is such that it is only a certain degree of removal. And even after that, what remains is of concern, something that affects the ecotoxicity and may affect the water cycle and eventually may affect our health. So photocatalysis, which I showed that it has a good potential for removal of pharmaceuticals, which is much better than that of photolysis. However, in photocatalysis also, we have to look at the impact of co-contaminants that can affect the result. Things like alkalinity, things like phosphate, fluoride, dissolved organic matter, all of this had some impact on the removal through photocatalysis. So the water quality is important when you are looking at processes like this. And even when we look at toxicity, we were like in our work, we were looking at only endocrine disrupting activity, but there are other effects also that can happen. The EDC activity reduced, but is it possible that some other type of toxicity increased? So these are thoughts that I'm leaving you with. We did not do all this, but this is just a thought. So the low concentration of a complex mix of pharmaceuticals certainly poses a challenge, both in terms of measurement and in terms of removal. With this, I will like to acknowledge the students who contributed to what I presented. They are all finished now. They have done their work and they are gone, but they have done excellent work. So Dr. Sanjeev Mahapatra, Dr. Gayatri Menon, Dr. Pujana, and my collaborators, Professor Lokesh Padhyay, Professor Shankara Tatiparthi of DESE IIT Bombay, and Professor Shoma Mukherjee of DSB IIT Bombay. And I acknowledge the funding provided by DHT Water Technology Initiative. Thank you.
Thank you very much, Professor Mukherjee. This was a very illuminating, outstanding presentation and some examples of very high quality work in this area. And one of your collaborators, Professor Lokesh, in New Zealand, right? So
right.
Yeah, kind of connection very recently we have between us as well.
Oh, I see.
Yeah, no, thank you, Professor.
Thank
Thank
you
you very much for your time today, actually, for in your very busy schedule to give this short presentation. I know this time is not enough to share everything. Since you will be leaving us soon, I would probably, like, our original plan was to take questions at the end of everyone's presentation, but since you need to go, so maybe I would open for 2 questions from the audience, from the attendees, if they have anything.
Sure.
I can see one from in the chat box from Praveen Reddy. He's saying, may I know the storage conditions, like how long can we store the samples after their extraction?
After extraction, you can store. I don't exactly remember how long we stored, but we tried to analyze as soon as possible. But you have to complete the extraction first. I mean, keeping the sample is without the extraction is not a good idea. It's better to extract and then store.
Yes. Thank you. Any other question? We can take one more question or queries for Professor Mukherjee.
Yeah, actually, I just have a quick question.
Yes, I had one too. Okay, go ahead.
Yeah, so we take 2 questions. Yes, thank you.
Okay. Yeah, I think actually, this is a very nice presentation in the data. I just have a quick thing that is, now we are analyzing the, pharmaceutical products, different kinds of antibiotics, and we know their concentrations. And also you have proposed a photocatalytic method of degradation for their removal or remediation, whatsoever it is. But the thing is, like, how far are these methodologies implementable at a level of, commerciability? Like, for example, commercially viability. This is the most important thing. Where by saying that in Europe, recently titanium dioxide has been actually banned from the catalysis.
Yeah.
So the thing is, like, because we are always have a kind of a trauma-like situation when we try to bring it up to a commercial viable situation. So can you please?
Yeah. So that I know that's an important consideration. So in this case, this nanocomposite, we could settle it out and remove. But what I would suggest is this type of material we have to use in an immobilized form, because we have been working with other nanoparticles also in the context of water treatment. And what we propose is not not dispersed in solution, but something that is immobilized on a surface. That way you are not having the nanomaterial in the aqueous phase. And so robust processes definitely have to be developed. But as I said, my foray into this area is relatively newer compared to my other work. So Gayatri is my first student who worked on photocatalysis for removal. So we have not looked at more advanced methodologies, etc. as yet. But we could show that fundamentally the material had a good characteristic. And if we can come up with a form in which the nanomaterial is not in the water, in the treated water, then I think that it is still usable. Because our leaching into the water was very, very less. Although we had TiO to ZNO, we explored the ZNO, the zinc and Ti leaching into the water. That was not less. So as long as we can have it in a form that the nanomaterial is not going out with the water, I think that should be okay.
Thank you.
Thank you.
One last one from Professor Kaur.
Yes, I'll be very fast. May I call you Suparna?
Yeah, go ahead.
That was such an awesome presentation. I have my student here, and I think he also enjoyed this because we have been talking about doing SPE, and we don't have so much expertise. Maybe I will write you at that time.
Sure.
Because now seeing your presentation, I'm a little bit unsure because you said that there's a lot of standardization that needs to be done for each pharmaceutical, right? You said that.
Well, if you are working with concentrations that are high enough, you may not need it. But I showed you the concentrations we were working with. That was very low. So we needed all that optimization. If you do not need, that's great. But because of our complex matrix and the low concentrations, we needed the optimization.
Okay. So we are usually doing risk assessment. So my postdoc supervisor is actually Daniel Dietrich, and he's a big critic of endocrine disruption in Germany. And he usually stands in the whole assembly, and he's criticizing how people are talking about this. One of the things we would discuss in all our certification courses, we are toxicologists, mad people. And one of the things we always talked about was only something which is reactive enough can cause endocrine disruption.
Right.
And I think this is something where you stopped actually, because you said that we have not looked at the products of biotransformation. And that is where we are always saying that if there is going to be a endocrine disruption or any kind of effect, any kind of organ toxicity, it is going to come from the biotransformed, active, reactive moiety.
But what we found is because these were hormones, we were looking at E2 and E2. They are known to, they are hormone. They are definitely they are endocrine active. So they did have endocrine activity, and we were monitoring the change in endocrine disruption, endocrine activity. So that reduced as the treatment was going on, that we found. But I showed you that very low concentration of products are formed. So my concern was that do they have any other effect that we do not know?
Exactly.
Toxicologists like you would be the best person to look into and explore
that. Because this is what we would do for practice, that we would sit with compounds or chemical, and we would try to find out what kind of reactive moiety it is forming. And actually from the moiety you can tell which organ it may affect.
Exactly.
If it's going to be a human, if it's going to be a human.
So interestingly, photolysis we found sometimes generates something that is even more endocrine active.
Yes.
So this is because it adds on OH groups and makes them more active.
Yes.
So these are things I think toxicologists need to explore. This is very important.
No, this is
because we
this
don't
is
have the
an
capacity.
yeah this is an area is like endless, and
Yeah.
not only this endocrine disruptors or this kind of chemicals, but every year more than 2,000 new chemicals are coming into the
Exactly. And where's the risk assessment? Where is the
Exactly.
risk assessment? And in India, it's especially missing. It's especially missing. Nobody wants to know what is going to happen when it enters the environment or, the system.
It's
Right.
a real global issue
Real.
these days.
Yes.
And like most of these resources that address these compounds singly, like one compound at a time.
Yeah.
But in real,
It's
when we
not
drink
that.
water, maybe tens of those compounds are going inside our body.
Exactly.
So what happens when we have that
We don't
mixture?
know.
So risk assessment is, and
Yes.
bioaccessibility, bioavailability studies are.
Yes, this is why I think they have been talking about adverse outcome pathways nowadays, to at least have the information for one chemical at one place. Because when you put it into this adverse outcome pathway, you can actually see how much of this dose is going to cause what, and this dose is going to cause what.
Right. But sometimes, the effects are not additive.
They are not.
There is synergistic effect, and that is
Yes.
the concern.
Yes.
Yes, because we have seen that sometimes the metabolite compounds are more toxic than parent.
Yes.
So I think that's why in our future project we would be very interested to include the health risk assessment, this component.
Now,
and we need experts like you.
Yeah. No, thank you.
You
Thank
have
you.
me all the time. Don't worry.
No, these
Ma'am,
are
Suparna, very good presentation.
Thank
I'm
you.
really
Yes, it was
happy to
excellent
have seen
presentation.
it. Really.
yeah, I do agree and completely with Professor Kaur. And thank you very much again, Professor Mukherjee, for your valuable time today. And we will be in touch, and let's see if we can do something together.
Sure.
Thank you very much.
Thank you.
Thank you.
Now, okay, I think Professor Prabina, she is from Malaysia, and it is quite late for her already. So I wanted to just ask her if Professor Prabina is there. Is it
I am.
is it all right for you to wait until, because your
no
presentation?
No
All right.
problem.
No, thank you very much. I
Okay.
apologize again for the little bit
It's okay.
delay in the program. So okay, in that case we can go ahead as our scheduled program. Who will then introduce Professor Darba?
Sir, I will be introducing Professor Darba.
Please.
Yes.
Thank you,
Himanshu, please.
Professor. Thank you, Professor Mukherjee, for your informative talk. Now I would like to call Professor Gopala Krishna Darba, Associate Professor, Indian Institute of Science, Education and Research, IISER, Kolkata. Currently, Professor Darba's research focus is on the safety concern of various anthropogenic contaminants under different hydrogeochemical processes and the role of colloids and nanoparticles in transporting the contaminants. Professor Darba has published in Nature Communication, Journal of Hazardous Material, and many other national and international reputed journals. Today, Professor Darba will be presenting on fate of micro and nanoparticles in the Lower Ganga Basin. Over to you, Professor Darba.
Let me share my screen. Yeah, I hope you're all able to see my presentation now. Okay. Yeah, first of all, thank you very much, Binoy, and as well as Dr. Shantanu for providing this opportunity. Yeah, and the title of my talk is about the fate of micro and nanoplastics in the Ganga River Basin. So, I tried myself to push in, to fit in as much close as possible to the main theme of the topic. And I find that some or other way, maybe I'm, overlapping my topic with the actual theme. So if you look at the pharmaceutical and personal care products, definitely yes, pharmaceutical, we always talk about the antibiotics. I totally agree with it. They are most relevant and important and significant. And when it comes to the personal care products, this is also something of very much environmental relevance, where I'm dealing with the micro nanoplastics. So, where we worried about microplastics is basically that there are a lot of food packagings where we use constantly the plastic made materials, to which we are one or other way exposed to these plastics. And also, if you look at the recent news, we always see that the most branded water bottles like Bisleri, even they do have contain a lot of these microplastics within them. And also, the most alarming news says that the infants are being exposed to several billions of these plastics to the milk, to the formula milk that is being consumed. Okay, now when it comes to the cosmetics, personal care products, by definition, the cosmetic is basically a substance that is used to change the complexion, skin, hair, nails, or teeth, and as well as cosmetic can be a product which can be of soap or shampoo or shaving cream or deodorant, whatsoever it is. And why are you worried about the plastics is because they do contain, these pharmaceutical products, cosmetics do contain plastics. And when we turn to the microplastics, these plastics are less than of the size of 5 millimeters. So when we are talking about nanoplastics, they also come under the classification of microplastics, even though unless we specially segregate them out of this microplastic. Whenever we say micro, that implies also a nano fraction. So what is the major threat? Function of these microplastics in cosmetics, they have different roles in the sense like they can be used for viscosity regulation, or they can be used for optical burning, for wrinkles as well as for exfoliants, and to increase the prolonged shelf life and so on. So knowing it or unknowingly, I think we are using the cosmetics. That implies that they do contain definitely a fraction of microplastic in it. And when we look at the environmental significance, where are you worried about microplastics from cosmetics, especially these personal care products? When they are washed through wastewaters, they may then be exposed to the aquatic organisms, and then further entering into the lower level of the pyramidal food chain. And we should all remember by one factor, that is, as we have seen from the earlier presentation from Professor Suparna, that pharmaceutical products, which are like organic molecules, which we can term them in terms of chemistry like organic molecules, they themselves are not actually totally removed during the wastewater treatment process. And when it comes to the actual water or waste treatment process, there are tremendous amount of scientific evidences to show that these micro nanoplastics are not completely, they don't have the ability, the water treatment plants are not designed to remove these nano and microplastics to a complete extent, which means that we are one or other way being exposed to these micro nanoplastics. That's what, it alarms to say that these microplastics are incorporated inside the food. And when it comes to the toxicity, considering the recent accidents in Visakhapatnam, where the styrene gas, which is the actual polymer through which the polystyrene is being made, which when the disaster, as we all know, it has impacted like several deaths and as well as more than 5,000 casualties. Apart from that, to say that the plastics are proved to show a significant toxicity in different parts of the human body which when exposed, it has also a direct impact on the fish itself. Now the next question is like, what products are we using which contains these plastics in cosmetics? So in the recent times, in the early 2000s, after the US government has taken up a decision to ban these microplastics in cosmetics, several products have eventually, tried to remove the plastics during the manufacturing process. However, still there are some products, which may contain plastics, including the toothpaste, which we might need help with. Yeah, so when it comes to the plastics, so majorly in our laboratory, we deal with the aspects of occurrence. That is, first we try to look at their presence in the marine environment or in the environment. And then second thing is like to look at their mobility. Like how far are they stable in the marine environment? That it actually dictates their accessibility to the aquatic species, and then their transformation. Like, how do they get eroded? How do they change the functionality of the surface morphology as well as the chemical transformation, which when exposed to either mechanical processes or the photochemical processes. And then finally, which when exposed to the fish, what about their toxicity? And finally, we don't want it to leave at this point, but also we wanted to show a remedial measure to remove the microplastics from the waters. And then finally, to go back and find out whether do we still have the micro nanoplastics in the environment or not. So this is a continuous process which can encompass to address the overall picture of microplastics in the environment. So today I have kept as a preliminary, not in detailed results, but an overall picture of what we have been working on, in terms of micro nanoplastics in our laboratory. So some of the few results to share with you is, we try to look at some of these locations in the lower Ganga River basin, and to quantify the amount of plastics, because there are seldom some results to eventually bring up some light to say that do Indian rivers, especially the Ganga, which is a lifeline for where more than 3,000 million liters of untreated sewerage waste is released on a everyday basis, and also tremendous amount of plastics. Do we have the data? No, we don't have it. Okay, so we are the first ones to actually work out on investigating the plastics. However, we have been delayed in publishing, and now we do also have some more results from other people on the Ganga River, which is very valuable, not only in Ganga, but I think if you would say that there are similar rivers where the data is lacking here. And what we did was actually that, we have chosen 5 points in the lower Ganga River basin, which is very much known for its pollution, like Balia, Patna, Bhagalpur, Farakka, and Diamond Harbour. And we tried to measure the plastics not only in water but also in sediments, because we know that the plastics might submerge with respect to microbial activity or photochemical activity. So it is very much important to know that what is the concentration, and we have found definitely a higher amount of plastics which are buoyant in water than compared to the plastics which are present in the sediment. However, these are like nearly more than 600 number of items per, you can say, 100 meter cubes of water. And most significantly, what we found was that most of the samples do contain, are dominated by polyethylene, polystyrene, and as well as polypropylene over compared to the other kinds of. And the most important result, what we have found from these samples was when we looked into the electron microscope, we had clearly seen the signs of their erosion and further disintegration to produce some smaller fragments, that is the tiny plastic debris, which eventually would have a higher surface area and higher viability for their transport and causing toxicity and further their so the next question what led to us was that what about these nano and tiny plastic debris, their fate in the riverine environment? Because in the rivers we do have a complex environment. As if you have done the sampling in the rivers, it would contain several amounts of organics. As Mr. Suparna said, that organics definitely play a very crucial role in order to address the fate of any contaminant, including the plastics. That's what we have seen in our results. So what will be the fate in the presence of organics? Their stability, how the stability of the plastics is dictated has been addressed here. And also with respect to the clays are highly unavoidable in the riverine environment. So clays also would dictate their fate. So here we try to address the fate of these nanoplastics with respect to the persistent organics as well as the clay particles. And what we found was we tried to understand their stability using dynamic lead scattering technique in our laboratory. And we found that in the presence of sodium chloride, the particles are very unstable, and whereas in the presence of humic acid, it seems to be that the plastics are stable. However, the situation is reversed when we added calcium chloride, which formed a kind of a chelation between the humics surrounding the plastic. That shows that the presence of humics can have other impact when compared to, it depends. I mean, it is qualitatively dependent on the valency of the cation that is present. And when we have added the clays to these polystyrene beads, we saw that there is a possibility of heteroaggregation, which shows that the plastics might submerge and reach to the bottom of the sediment of a riverine system in the presence of huge amount of these clay particles. And finally, we found that these plastics are definitely highly unstable in the riverine, marine environment. And then it comes to the river and the groundwater. So we found that the river water, the samples are unstable than compared to the groundwater. Because in groundwater, we do have higher running strengths. Instead of that, we have seen higher stability. And this was attributed to the higher amount of organic content. Again, as I said, that organic matter played a crucial role in determining the fate of nanoplastics in the riverine environments. Then, we also try to look at how these weathered plastics, because in the environment, as I said earlier, these weathered plastics behavior is totally different to that of the pristine plastics. So the next question is like, we have taken the plastic and we led it to weathering process in the laboratory. And this you can see there is a clear change in the surface morphology. And we wanted to see how the change in the surface morphology of the weathering would impact the interaction of co-contaminants such as cerium oxide nanoparticles. That these plastics would then act as vectors to transport these cerium oxide nanoparticles. And we had seen that there is definitely a very higher absorption of the cerium oxide nanoparticles on the weathered one than compared to the pristine plastic. That shows the association property and also their possibility to be transported, cause a secondary pollution in the riverine systems. Then, one of my students, actually, she has a kind of interest in biology, and she had went a step ahead to understand the toxicity of these plastics in the presence of metal nanoparticles and as well as the polyaromatic hydrocarbons. So, what she found was that in the presence of metal oxide nanoparticles, the DNA damage was increased over the time. However, in the presence of polyaromatic hydrocarbons, she had seen there is a decremental effect. The toxicity is still there, but it is not at the mark of having the presence of metal oxide nanoparticles, which is attributed actually to the interaction between the polyaromatic hydrocarbon and the plastics hydrophobicity. So what we have concluded was that the plastics in the presence of metal oxide nanoparticles, definitely they are unstable in the riverine systems, and they are causing the highest damage with which when they are exposed to the fish. But in the presence of polyaromatic hydrocarbons, we had seen definitely there is a toxicity, but not up to the mark of the presence of metal oxide nanoparticles. Then, we have also done some work on the removal. This is for the first time we have reported in the literature on the removal of nanoplastics that can be implemented directly as a supplementary treatment method for water treatment processes. So where we had used a biochar, which is actually a product from agricultural waste, and this has been magnetized using iron oxide nanoparticles, and we synthesized a product called magnetic biochar. So this magnetic biochar, which when added to these plastics which are suspended in waters, and then once we apply a magnet, these plastics are eventually being separated from the rest of the solution, leading to a clear plastic-free water. And what we have done was like we have tried to apply different kinds of nanoparticles, like maybe the charge, we have varied the charge, like positive to negative charge, keeping the same size, that is 1000 nanometers, and also we have varied the size to 30 nanometers, keeping the same charge like negatively charged. And we have taken two kinds of biochar. Maybe the one which is treated at 550 degrees, the other one is at 850 degrees. Maybe the hydrophobicity or the carbonyl index may play a critical role, so therefore we have tested. And we have seen that both of them seems to have almost the same ability to remove almost like more than 98% of the plastics from the waters. So that shows a clear applicability of these particular biochar, magnetic biochar for water filtration systems. And coming back to that, these are following publications with respect to plastics. So as I said, like plastics is one of the area which we work in our laboratory, apart from the topics which we address. And, this is my group, and Nisha and Ekta, these are my PhD students. She's about to complete her PhD, and she's the one who has done most of the work here. And I'm thankful to the funding agencies like CRB and as well as my research institute and as well as my collaborators from various places from Europe. And I thank you very much for your attention.
Okay, thank you, Professor Gopala. It was really a very directive information and a very good information about the microplastics and the use of biochar and how, and you have shown that how biochar has the potential to remove the microplastic to more than even 90%. Thank you, Professor Gorba. I am also working here. I've started just to work on biochar, and I would hope that we would be happy to future in good collaboration. So now I would just open the floor for 2 questions, and please, any 2 questions from the audience.
Since no one is raising their hands or hasn't written anything on the chat box yet, so I just occupy the time a little bit. Thank you very much, Professor Darba. It was a outstanding presentation.
You are most welcome, and also I welcome. If there are any questions, please feel free to write me by email.
Yes.
I'll be more than happy to come back with answers.
Yes, absolutely.
I will definitely write you. I will definitely. Maybe if you stick around my presentation, I don't think I need to do a presentation anymore. Because I was going to talk about microplastics and pharmaceuticals. This is excellent work. I really don't know what to say. I'm just happy to be here, to have absorbed this much.
Thank you, Professor Kaur. Yeah, that is the aim of our networking event, that we find real expertise so that we can make our research multidisciplinary. We can look at different aspects of a particular issue. So that is the aim of our networking event, and especially these microplastics and the nanoparticles interaction. Microplastics itself, it is called a carrier, or is called the Trojan horse for various contaminants, inorganic, organic. And if a nanoparticle or supported nanoparticle can deal with them, that is outstanding. That is a real, feasible treatment. But Professor Darba previously made a comment that how to make these processes scalable, how to implement some of these methods at a large scale. So that is probably something we need to think, and we need to develop our work packages for the future. So yeah, I am like Professor Kaur. I am also excited and impressed that the kind of inputs we are getting.
Exactly. And this work that he has done with this biochar, we tried this, but Corona hit. So we could not finish the whole thing. We could separate it out, but we could not go for characterizing after that. We tried something very similar.
Yes.
So I don't know if I still need to present. You have to tell me.
Of course. Professor Pardeep Singh has a question. Please,
Okay.
Professor Singh.
Okay, so thank you. So I think it's a wonderful presentation. I have a very simple question because recently I have worked on graphene-based adsorbent. So nowadays biochar is getting very, I would say, due importance as compared to graphene. So just a question, which one of these two is more better as an adsorbent, graphene or biochar?
So
Professor Darba, maybe you may like to address.
Yes.
Yeah, I'm sorry. I think I have muted. Yeah, that is a good question. Okay, I mean, the thing is, basically, we have to make our stance clear in the sense that graphene definitely scientifically has much more ability to remove the multiple contaminants. Definitely, yes. But now we are looking at the costs. We are looking at the costs, then the biochar will play an important role, which has a multiple functionalities, which has also equivalent capabilities to that of the graphene, may not be comparable with graphene, where graphene might eventually 1 gram of graphene might eventually filter about nearly more than 2 lakh liters or more than that, but whereas biochar cannot. But at the level of synthesis, for example, like graphene, if you look at graphene oxide to graphene and multiple layers, graphene to single or mono or two-layer graphene, the costs that is incurring, if you look at it, I think biochar has definitely an edge over than compared to the graphene. That is how I compare in terms of cost and as well as the efficiency.
Okay, thank you, sir.
Yes, and I also like to add one point, sir, as we have already discussed that that biochar is a good tool for waste management. Nowadays, people are talking for waste to wealth. The greater thing with biochar is we can prepare biochar from any waste material that is not of any use. So, of course, the cost, the local availability, and we have to employ very low human resource for this. So, this is the thing, and it's of course a very good tool for sustainable waste management. That's it.
Right. I mean, we had tested to remove several other, like dyes, for example, from the wastewater. Okay, and we are applying also to the actual waters from from a textile industry, and the materials like the clays with biochar with iron oxide nanoparticles, which have been modified in our laboratory, are showing some tremendous good results actually. So these materials are very inexpensive than compared to the graphene, and we don't have to maintain some extensive preparation for simplified proprietary methods. This involves also the cost effective methods.
And sir, regarding biocompatibility?
Biocompatibility, yes, that is where this is one of the major next stand. Good question, because see the materials what we choose, say for example, the biochar is not actually a toxic substance, and what we use iron nanoparticle, for example, is not toxic. And as well as we used clay particles, especially when for our synthetic methods. These are also mineral. So these minerals we are consuming on everyday basis, knowingly or unknowingly. So these are not at all toxic substances, which when actually exposed or which are disposed after the removal process, they don't cause any kind of environmental vulnerability.
Okay, sir. And sir, one more personal question. Sir, are you a chemist?
Yes, I am an environmental chemist. Of course, I'm a chemist.
Okay, okay. So I love your presentation. So might be I approach you in future.
Definitely, I look forward to it. Yeah, thank you.
Yeah, thank you. I think these clay and biochar, this type of stuffs,
Yes.
regarding their biocompatibility. Like on one hand, they give the circular economy tick of the work, and then the resource recycling, getting wealth from waste, and then the environmental benignness of this type of materials. Like I have some experience working with clays and clay modification, etc. So we have done plenty of tests in microbial and organism level, and they are really, like, they are naturally present in the environment, soil or in sediment environment. So these are probably the way forward in terms of nanotechnology is concerned. Instead of synthetic nanotechnology, natural nanotechnology.
Yes.
Yes. So clay biochar can be an outstanding combination for which can have the multiple options for and multiple role in the remediations, I think.
No, thank you, Professor Darba. And yes, he is a chemist and he has publications in JAX as well. So, no, thank you. So, thank you, Professor Darba, for your valuable talk. So maybe we move forward and to Professor.
Yes. So now it's the time for Gurjot. So Gurjot, so Rajiv, please introduce Gurjot. So
I'm not sure what Rajiv is going to do. I'm half scared sitting here thinking, okay. All right, go ahead.
Thank you, Professor Darba, for your insightful presentation. Next up, we have Professor Gurjot Kaur. Professor Gurjot Kaur is currently working as Associate Professor at our own School of Pharmaceutical Sciences in Shoolini University. She is a toxicologist by training and an environmentalist by passion. Professor Gurjot holds two postgraduate from University of Konstanz from Germany. One is in neurobiology and another one in toxicology. She is also actively involved in leadership roles in Society of Toxicology and loves to blog about science. With over 6 years of teaching experience, her academic contribution includes several international scientific papers, reviews, book reviews with chapter, edited, and author books, which are published in Elsevier, Springer, Nature, Taylor and Francis, and Wiley. With over 474 citation, 8 H index, and 7 I-10 index. The thirst area of Gurjot Kaur ma'am's research is human and environmental toxicology, especially air and water pollution. At present, she is engaged in research to develop sustainable environmental remediation technology for pollution prevention and control. Over to you, ma'am.
Thank you, Rajiv. I think you meant postdoc and not postgraduate.
Sorry. Apologies.
No, it's completely okay. I'm even more scared than you are because I am just presenting an idea here. I'm not presenting any data. It's been a few years I came to Shoolini, and my first PhD student is still working on the idea. So I'm just going to give you the idea, one more idea that she's working on. Can you see my screen?
Yes, Gurjot, but there are no slides yet. It's only blank.
Okay, I'm just gonna wait. Can you see it now?
We can see all okay, yes.
All right. So the topic of my talk is what is in the water. And I want to, as a PhD in pharmaceutical sciences, I would like to connect pharmaceuticals with microplastic. From the previous talks, it is very clear to all of us that pharmaceuticals are also present in the water and microplastics are also present in the water. I put this photo here just for the people who are not directly linked to microplastics. These are, let's say, debris or very small micro-sized plastics, less than 5 millimeter. And as you can see on the finger, this is how they would look like. And on the dish, you can see that there are many different sizes, shapes, especially because there are many polymer types involved. The idea that I'm going to discuss in this talk is that microplastics have this varied surface. Okay, do not forget many polymer types, many shapes, many crystallinity, like amorphous, it can be crystalline, and also these crevices that Gopala also showed, that there is so much on the surface of a microplastic which can lead to different types of interactions, which are shown here, that something like an organic contaminant or pharmaceutical could interact by the spore filling, by hydrophobic partitioning on surface, or some hydrogen bonding. Yes, that's possible. Some pi-pi interaction could also be there. Some, very weak interaction like a Van der Waals interaction can also happen. So there are many factors that are, involved in this. If you look at this image, just taken from a paper that came out in 2021, where they have shown that different types of polymer types are interacting with anti-cancer drugs or antibiotics or, beta blockers, and they looked at different types of factors. So there's a list of these factors that we are putting to you, that, for example, environmentally, this, I think Suparna also said, Gopala also said, that the pH matters. The pH of the solution is going to matter. So if it is acidic pH, if it is basic pH, this all is going to affect what kind of absorption you're seeing on the surface, what kind of interaction. Some ionic strength, mechanical stress is also going to cause differences in the surface. Aging, of course, is going to change the surface features, and this is also going to affect. And of course, if there is organic matter, so in for example, soil experiments, they see that the soil, the microplastic is embedded into the soil, and then this causes the effect of how the bacteria in the soil are interacting with microplastic. There are physiochemical properties too. These could be physical properties and chemical properties. Physical, I already said, it could be the size of the particle. The smaller the particles, the more concentration of these particles, and therefore more surface area in total for any kind of interactions to take place. The shape of a microplastic can also decide this, because the surface area is also involved here, so the shape is also involved. And of course, if it is amorphous or crystalline, which is directly in a way also linked to, chemical property of functional groups. So some other chemical properties are also important. What functional group is there? So for example, if the particle is aging by oxidation, photooxidation, then you're going to see a certain type of functional group, gradually increasing. And for example, if you're taking polyethylene, you will see in the FDR that there are differences in the functional groups that were present. They are most probably degrading into a oxidizing group somewhere. Same goes for other properties, like you can also look at adsorption kinetics, which is, in a way, I will be discussing this in the next slide. So what we did was to show you that this is a thrust area, because the publications that came out, if Corona would not have happened, I think this would be huge. They started coming out in 2018, and there are more publications coming out. We are still making this list, and you can see on the left side on the second column that various pharmaceuticals are listed. Various types of microplastics are given here for you. So you can see that the interaction of these doesn't matter if it is ciprofloxacin, but if it is with polyethylene or polystyrene, different type of interactions can be seen. So with the same pharmaceutical, the same way, if you go, for example, sulfamethoxazole, and you look at the data here, some kind of electrostatic repulsion has been reported, and this is because of the negative charge that is carried by sulfamethoxazole. But this is a huge thrust area, and one of the reasons exactly is this, that now both are being found in the wastewater. So one of the questions, that is why I asked in the starting, was what are you measuring? Which pharmaceutical are you measuring? Are you measuring dissolved? Because you have to think of it like this, that this decides the half-life of that pharmaceutical in that wastewater, just like in those sludge solids, when it is stuck there, the half-life is going to increase. That before, if it was passed on in, let's say, 10 years, now it is incubating and incubating there for a longer time. But this slide is just another example of the same thing, that if we look at, for example, that we look at tetracyclines here, and we see that different type of polymers, microplastics, are involved. You can see different type of interactions are present for the same pharmaceutical. So if you look at it from nature point of view, if you think of, let's say, in the water, you have these various types of polymer, type microplastics, and then you have some discharge of tetracycline into this water. What is going to happen? Right? So all of these have the propensity to interact with tetracycline, right? And this is going to decrease what we are going to measure in the dissolved state. but it is still there, right? So this is one of the points I wanted to put forward, that what we also need to look at is how much pharmaceutical is getting absorbed onto the surface of microplastics, polymers in general. Another point that I want to point out is what happens when this microplastic adsorbed PI comes into contact with biological system. What exactly Gopala was talking about. What happens when this comes into contact? So because I'm a pharmacy graduate, I think of it like this, that let's say I have propranolol. It is reported that propranolol also gets adsorbed onto microplastic. And now this propranolol is in the wastewater, and let's say people come into contact with this. So I would be thinking like, okay, so this propranolol, is it active? Does it get released in a biological system? So what is the release rate? This is why people have been talking about adsorption kinetics. And I think what they should also be doing is looking at the release kinetics. If it is put into microplastic, then is it getting released again into the system? Is it getting degraded? And how it is going to affect a biological system? One of the major biological system that will be affected and is getting affected, and it's widely reported, are bacteria. And they're also part of us. They're part of the soil, right? They're part of marine environment, and they're part of all the living, human, animal. So I really congratulate you guys. You're looking at antibiotics. This is going to be very important from that point of view. I think we should really look at what happens if PI adsorbed MP comes into contact with the, a biological system. I just put some, images here, just for people to have a visual. I think we already understand it, so I will not spend so much time. So when we look at these SEM images on the side, you can already appreciate from A1 and A2. A2 is, a little magnified image, and you can see how the surface of the microplastic can be. So you can see this in A2, B2, and C2, that if we look at the surface, how the surface can really vary between microplastics, with various microplastics. And of course, this is why this adsorption can really be affected. On the right side, you see a FTIR spectra, and this is just a spectra of tetracycline and polyethylene, and of course polyethylene and tetracycline together. And you can see that there are changes. You don't really see a new functional group coming up. You actually see changes, because they interact. So that side is, that functional group is covered up, and therefore you see this in the FTIR. So you could even do this with FTIR, which is a much simpler technique. If you want to, you can of course do LCMS, and you can also do other techniques. Just to give you an idea, the adsorption can be various ways, right? So it can be, for tetracycline, it is reported to be pseudo zero order kinetics. But at least the adsorption kinetics, people have already started studying. This paper came out last year. I think one of the things that should be looked at is the release kinetics too. Like, just looking at it from a different point of view, and not just how much is adsorbed, but is it getting released? Because that is going to decide the toxicology around it. If it is really environmentally, do you really want to look at it environmentally? How does it affect? All right, this is the idea we are testing right now, that we are looking at these different parts. We are looking at MPs from water resource. We are looking at the pharmaceuticals adsorbed on these microplastics. We are trying to study the pharmaceutical half-life. And of course, as a toxicologist, we are trying to study the biological effect, like how is it really causing some kind of an effect. All right, I'd like to stop here and I can take any quick questions.
Okay, thanks, Gurjot. It was really good presentation. As I personally say, I work on the adsorption, desorption. So now I should remember that also with adsorption, I have to study desorption. Well, this is very important. Yes, I fully agree that also desorption kinetics, release kinetics play a big role for considering contaminants, slow release behavior. Okay, so now the floor is open for questions, comments, and suggestions. So I would request the audience to ask maximum 2 questions, and I think Gurjot will be elated to have that.
Yes.
Please. I think Gurjot, you are clear to each and everyone.
I hope that means clarity and not.
Actually, I just, please, Vinay, maybe.
No, please, Gopala, you go first. Yeah.
No, I think, I definitely see a lot of, I would see a overlap and as well as a complementary component here to many of us, I think, with respect to absorption. Okay, absorption is actually also one of the core component of our research where we use, this concept to remove metals from, water and wastewater. Okay, but this particular thing, like understanding the interaction between the pharmaceutical products and as well as the plastics was something we have thought actually about nearly more than 2 years ago, which we could not advance because we were already handling too many projects. So, but I really, as you said, because of this COVID, maybe it has little hampered unless that this work is really going at a rapid, at a next level. And I think, however, I should tell one thing that you see, no matter what, we generalize the studies. For example, we conduct different laboratory-based studies by taking some very well-known plastics, okay, because we need to have a standardization, I understand. And now we add different kind of pharmaceutical products, that is also fine. Okay, and then we study about absorption, okay, and we do in a systematic way. I totally accept it. However, the actual problem for me has been when I had to actually apply the concept of absorption, okay, which is actually utilized for fundamental understanding of interaction for the actual removal of a contaminant. Okay, so that means understanding is fine where we scale up the experiments in such a way that we increase the difficulty by one or other way, and then we try to keep it in a very good story. That is all fine. But when it comes to actual application, the end product, they always demand to say that I am giving he will dump me with a kind of a environmental sample where the students actually have the research scholars have actually come up with the river, okay, and then you say you purify it, you remove you actually and now the problem is like I have to use the concept of absorption, but actually I have to apply it to
understand release. Yeah,
exactly.
Yeah.
So what
Water of a whole river.
Exactly, so what happens is like in the environment we do have like synergistic effects which we have to accept it, which are very complex and very critical and very difficult to deal with. So I think, I mean,
this was my reason to show this table, because to tell that you can't just say that polyethylene is interacting with tetracycline in this way, because hey, look at this literature, which means that it doesn't matter if you have different types of, and it's not just different polymer types, it's even the crystalline surface. You take polystyrene and you take aged and you take the nascent one and you already see a difference. It's a really, really difficult question to answer. I mean, to you too. I'm not alone.
Yeah.
It's a very difficult question. Yeah.
Okay. Okay, okay. Okay, Gurjot, you have one question from the chat box, a very nice question. What do you think the interaction of microplastics with soil clay?
Okay, I'm going to be honest. I'm not an expert on soil clays. What I can tell you, because one of my students is working on soil bacteria, and when we looked at the literature, we saw that depending on the different soil, it's an acidic soil or it's a clay soil, or there was even a very interesting word, some type of soil. Um, it differs. So the microplastic interaction with bacteria differs. So I'm guessing it has to do with the soil. It has to do with this pH, ionic strength, all those environmental factors that I told you.
And the zeta potential.
Exactly.
Yes.
So definitely it will differ. You have to think of microplastic as a chemical molecule. For example, many chains of polyethylene stuck together. Let's put it this way. And there would be functional groups on top of it. There would be surface crevices, and there would be, amorphous or a lot of things. So that's all I can say. I'm sorry if I could not answer that.
But it's a nice question. I think it would be interesting to address because clay is a negative charge, It's a negative charge particle and it's also colloidal particle.
Gopala,
Of course,
and
it's a
you would
good
like to
question.
add anything because you have done some real world experiments with clays.
Okay.
Yes, actually, yeah, this is definitely a good thing. Actually, we have done some extensive studies on the metal oxide nanoparticles and their fate in soil, different kinds of soils, especially the four kinds like red soil, alluvial soil, black soil, and laterite soil. Okay, so I mean, and then we had clear knowledge. I can say that with respect to how and what sort of for example, the soils, as you said, like clays would dominate their behavior, surface behavior, and more than anything, organic matter also plays a very crucial role in dictating the behavior of overall soil pore water and as well as the soil grain porosity and so on and so forth.
Yes.
So therefore, once we place the plastics in the soils, and now we are looking at the interaction with respect to other contaminant. Yeah, so that becomes very complex. As I said, it becomes very complex, and we have not yet explored. Okay, so far what I have seen is like with respect to the transport of nanoplastics, the people could not succeed. Why? Because the soils have a great filterable ability. So if at all we want to take a soil of column, say for example, at the worst, at the least like 5 centimeters, 5 centimeters is not representative. Even if you take 5 centimeters, you require very high amounts of nanoplastics to allow them to flow through the column in order to see a breakthrough, which is going to be very expensive and is not going to give you. So the soil itself has an ability to filter the plastics.
Yes.
Okay. So that is, I mean, only what we can see is like with respect to soil pore water, we can understand the porosity, we can understand the stability, and as well as the its ability to release some other metal oxide nanoparticles as a soil fertilizer and so on. That can be something that can be explored.
Yes.
But as such, the plastics, when it goes from nano to micro, they cannot filter through they cannot permeate through the soil different layers.
Yes.
Very difficult unless you have higher hydraulic conductivity.
Yes. No, thank you. Yeah, this has been very insightful discussions after all of our deliberations. So, and we have a brainstorming session actually at the end as well. We dedicated some time to have some discussion. So I hope that some of you would be able to stay. I know it is late already, but please do stay. And we have 2 international speakers now, I think. So we will have a discussion again at the end.
Okay, so thank you, Gurjot. Thank you for your nice talk and nice information. So now I would like to invite our first international speaker, Professor Lê from Vietnam Academy of Science and Technology. Professor Lay is an associate professor and head of Laboratory of Environmental Chemistry at the Institute of Natural Product Chemistry in Vietnam Academy of Science and Technology. She obtained her PhD from University of Paris and Marie Curie, France. She is the coordinator of Friend Water Program for Asia Pacific region, and she is the scientific member of IGCP UNESCO Council on Hydrogeology and Navo State Vietnam on Earth Science and Environment. She has she is the project coordinator of Friend Water Program for Asia Pacific region, and she has numerous number of outstanding publications in Scopus Index Journal like Stoughton Marine Pollution Bulletin, for Frontier Pollutions. So, and she is also working in the area of emerging pollutants. So now I would like to welcome Professor Lay, and we are very much interested to listen your talk. Please, Professor Lay, is your floor.
Thank you so much for inviting me to participate the meeting. And I found that the meeting is very interesting since the beginning. Here I already saw the PPT for me.
So, Professor Lay, yes, Professor Lay, we have already shared the screen and uploaded your PPT on behalf of you. Please.
Okay, thank you. So wait for me 1 minute. I will show the full screen. Okay. So I could start now. So I'm Lê Thị Phương Quỳnh as president. So today I want to show some research result on emitting pollutant in surface water in Hanoi. Due to the limited time, I just say some significant result of our laboratories or some result in the literature for the water surface of Hanoi. Next, please. So as you know, human activity and climate change has been impact strongly to the surface water, to the inland water. Human activity at deforestation and land use change or different intents of farming practice or increase of population or urbanization or industrial development without wastewater treatment in the especially in the large city, combined with the climate change has induced largely to the inland hydrology and water qualities. It's not the concern on the inland water quality, but also on the ecological of estuary or coastal zone. Next, please. So water pollution now is widely occurs in the world. Many kinds of pollution like methane, like pesticide, like pathogen, like pharmaceutical, and now we have some new amazing pollutant like make microplastic or cyanotoxin. Next, please. And you see here the population increase very quickly in Vietnam with the increase of fertilizer utilization for crop production. So we have both total fertilizer utilization and synthesis fertilizer, but the crop production has not increased as we expect. For population in Vietnam, we found that this is a data found. So we found that both rural and urban population has increased very quickly during the 50 years. Next, please. Could I change the slide? Could I change the slide? Next, please. I don't know how to change the slide. The next slide.
Who is handling the slides?
Yes.
Okay. Yeah.
Yes. So the objective of our work is establishing the data sets of water qualities, especially emerging pollutant in the part of Hanoi. And during the project of APN, Asia Pacific Network of Global Trade Research, we establishing the data sets of water qualities of seven large cities in Asia. But here I saw only the data sets of the Hanoi. And other objective of our study is point out the need for further study of emerging pollutant in urban surface water like Hanoi or other large city to show the needs for sustainable development in Hanoi for better managing of water qualities and environment. In this presentation, I saw only about the some written of cyanotoxin or antibiotic or microplastic that we has been carried out in water surface of Hanoi. But we have still have also carried out also other variable like a heavy metal, like a pop or another variable of water qualities. But this for the next step. Next, please. I don't know how to. Okay, so maybe you know a little bit about Hanoi City. This is capital of Vietnam, and the population of this city is now about 8 million inhabitants with a high population density. But I know that in the city we have seen some activity like industrial development, like agriculture practical. And in this city we have dense river and lakes and canal, but the water quality is quite poor. Next, please. I don't know.
I'm very sorry. Internet is little slow here, so sometimes your voice is not clear.
Okay,
I'm very
thank
sorry.
you. Thank you. So this is some river in Hanoi. So you saw the last river, the Red River, goes through the Hanoi city, and we have some urban river like Tô Lịch, like Nhuệ, or some peri-urban like the Dai River here. And you can see also some picture of the river with the very poor qualities of urban river like the Tô Lịch here, the Nhuệ here, but the Red River is quite a large river. So the quality is quite different with the urban river. Next, please. So first, I introduce about the cyanotoxin in our study. So you know the nutrient excess in different activity of agriculture, untreated domestic or untreated of industrial wastewater. So discharge into the hydro system, and with the other favorite condition to accelerate the development of algae, we call eutrophication, which occurs in many places in not only in Vietnam but also in the world, and for especially the lakes and river in urban river in Vietnam. Many cases of eutrophication already published. Next, please. Next, please. Ôi. Next, please.
Himanshu, are you able to hear?
Could I take sharing screen by myself? Maybe it's Better?
Yeah, that was even better, I think.
Okay. So here you could see some information concerning lakes in river. This is a not large lake. For example, the Hoàn Kiếm Lake is the center lake of the symbol of lakes in Hanoi. Hoàn Kiếm Lake here is the the third picture, and with the West Lake of the Hồ Tây we've been lake in Hanoi, and before this lake received the untreated domestic wastewater bleeding into the algae bloom in Hanoi, and the algae bloom including toxic algae. So I will show toxic algae in the next slide. Okay, so here's some reason of cyanobacteria bloom in Vietnam with Hòa Bình núi Cốc Ba Bể is a quite a large lake in North Vietnam, but Hoàn Kiếm, Thành Công, Giảng Võ, Thuyền Quang are the urban lakes in Hanoi. So you can see the hypertrophic of this lake, and you can see also some species of algae which is toxic cyanobacteria. And here is the Hoàn Kiếm Lake. We can see also the microcystic algae anaerogenosa. Next, please. Next also. So with the Hoàn Kiếm Lake, we detect the microcystin concentration in the water bloom and from the isolated sample. And microcystin found here with the LR or LR form with the concentration here in microgram per liter. So this is the toxic of cyanobacteria released. We call cyanotoxin. This is one kind of cyanotoxin. We have also many other kinds, but in this presentation, I saw only the microcystin. Next, please. So now I show about antibiotic. This is you already know the pathway of antibiotic in the aquatic environment over the world. For Vietnam, antibiotic is widely used for people, local people by using daily or for farming or for aquaculture farming, many purpose. And in Vietnam, the use of a certain antibiotic in animal food production already released, but people still use some antibiotic in aquaculture pond farming. And however, until now, we have limited observation or monitoring of antibiotic residue in surface water. Next, please. Okay, this is the redone of our group for antibiotic in surface water of 4 urban rivers. This is the Tô Lịch, the Kim Nghiu, the Lư, and Set in the center of the Hanoi city. We take care about 8 antibiotic and found ammo-oxim and lean detect in own sample of 4 urban river during 3 sampling campaign in 2020 with some antibiotic with the high concentration. Next, please. Okay, so we also collect the data from other author, and this is the first link is our return of Forwick Bend River, already published in Lee and Ann 2020, and we compare here with the other research return, and we found the how to say this is a different periods. So we found the increase, the chance of increase of antibiotic in surface water in Hanoi. Next, please. Here we present some result on microplastic in Vietnam and in Hanoi. As you know, the microplastic with the size and also the circulation of microplastic in the world in different environment like atmospheric, like soil, like water, and also including the sea. And here I present on the surface water in Hanoi. It means the fresh water. Next, please. So microplastic in Vietnam is a new study because we could see that for publication, we found some publication in a very recent year. Even Vietnam is the 4th largest amount of plastic debris the sea, published by Zembeck and R 2050. But until now, there are some first publication of microplastic in the presence of surface water, but we have no regulation for microplastic concentration. So I note here a case of research in the Saigon River with the fiber and fragment are very high due to this is a urban river, and we can find very kinds of very many kinds of size and how to say kind of size, and also different form of microplastic in the urban river with a high concentration. Next, please. Okay, this is the old version. Here we show some image of water sampling for microplastic in the Thao River. This is the upstream of the Red River with a net. This is in the framework of the Compost project and also other project funded for by IRD France. Next, please. And here you can see the Tolik River with the black color, and we found also the net for collecting the microplastic in surface water. Next, please. Next, please. Okay. Okay. So what after collecting the sample in the field, we do the observation in the laboratories by different steps proposed by Strari et al. 2020. This is also in the Compost project. Next, please. And here I saw some microplastic concentration in surface water in the Tolik Bend River and also in the Peri Bend River. This which we found a fragment and line are min size, and also the color of purple. By micro FT analysis, we find that the PA and PP are the main microplastic found. Next, please. Okay, so due to the limited time, I saw a very quick result of data on emission pollutant in surface water in Vietnam and notably in Hanoi. We found that the lack of database and wastewater treatment facility are difficult for managing, and we may develop the research on the impact of emitting pollutant on human health or environment in Vietnam. This work indicates the urgent requirement for regular monitoring of the national program to establish a complete database or study on phase and risk of assessment or propose some policy for sustainable water resource management in Vietnam, especially for large cities. And our group may develop the research in the Red River for microplastic contamination or antibiotic or POP or cyanotoxin. And also to develop some research in Hanoi City for surface water for continuing this reviewing. Okay, thank you so much for your present. Thank you so much for your attention.
Okay, thank you, Professor Lay. It was really very nice information, and we came to know lot of emerging contaminants. So now, till now, we are only talking about antibiotics, pharmaceuticals, but now you gave us also idea on cyanotoxins, cyanobacteria, how the algal toxins can be also lethal or can also be detrimental for water quality, that we get to know from your presentation. Thank you, Professor Lay. It is really very nice presentation. So now I would ask the audience, please ask 2 questions. There are on floor. The floor is open for questions.
Yes, please.
Okay. Now, I would like to thank again Professor Lay for her time to give this presentation and sharing with us the scenario in Vietnam in the emerging contaminants aspects. And one of the reasons that this UKRI funded Global Challenge Research Funding Scheme, this scheme allows us to work in developing countries, and we often, the big project, GCRA project, they often include multiple countries. So we thought similar issues, it's a global issue, isn't it? This emerging contaminants and PPCP contaminants, these are global issues. So we thought to learn what are the situations in Vietnam, and you have given a fantastic overview of the Hanoi city around and the rivers therein. So thank you very much, and hopefully we will be able to discuss more how we can in the future can work together.
Yes, thank you so much.
Yeah. Any question for Professor Lay from the audience? Anything in the chat yet?
No, so I
no.
don't see.
Okay, in that case, maybe we can move forward. And thanks again, Professor Lay.
Yes, you're welcome.
Yes.
Thank you, Professor Lay. We would be happy to collaborate with you, because we need some countries, as Dr. Sarkar mentioned, the South Asian developing countries. So we will work together and we will formulate some project, surely. Okay. Thank you, Professor Lay. Thank you. Thank you.
Okay, we are almost at the end of our event today. So we have another international presentation, here we are going to learn about the experiences in Malaysia. And this presentation will be delivered by Professor Sarvamangala Pravina. She is an associate professor at University of Putra, Malaysia. And she has done her PhD from University of Sabah. And she has decades of experience working with emerging contaminants, including these PPCP compounds, for example, the estrogenic compounds. And she has a prolific research career, actually. She has not only worked on this PPCP, but also has done significant amount of works on other emerging contaminants, for example, nanoparticles, then electronic wastes, pathogenic wastes, etc. And she sits actually at a medical school at University of Putra. So here comes the connection, like this environmental contamination, toxicology, and finally human exposure and health impact. So she will be sharing some of her research with her. And I should mention also that she is one of the winners or awardee of the Grow Burnt Land Award, which is Women in Sustainable Development Work. So many congratulations for that, Professor Pravina. And I welcome you to give your presentation. So the floor is yours.
Thank you, Prof. Binoy. Let me share my presentation. The slide can be seen, right?
All good, yes.
Yes, thank you. Good evening, everyone. Thank you for inviting for this virtual networking event. Special thanks to Prof. Binoy. We just met twice, and he has invited me to share some of research finding on emerging pollutant in Malaysian river water. It's just a sharing session of findings, and mostly to highlight the possible sources which have contributed to the emerging pollutant in Malaysian river water. So before we move on to the finding, I would like to give you a generalized information about Malaysian river water. We have around 477 rivers in Malaysia, where there are ambient and baseline stations which been monitored regularly. And then we do have upstream water intakes that involved in this monitoring, where 55 of them, because this raw water will directly go to drinking water treatment plant to be treated. At the same time, we do have this 35 station for River of Life projects. This is actually exactly what Prof. Atul Khoshla mentioned, where sometimes when you have financial difficulties, the best is to work together along with NGOs, government agencies, and the public to make the river clean. I'll give you one example, one of the successful example of River of Life project in Malaysia. Okay, so river water monitoring in Malaysia is actually, this is a Malay word. This is actually a Department of Environment in Malaysia. This is the government agency that manages the regular monitoring. And this is the common parameters involved in their monitoring. Start from ammonical nitrogen until total coliform. These are the parameters that being analyzed because they need this data to be included in river quality index. River quality index will give a direct understanding how many rivers are polluted, how many are clean. So this is a general river water quality trend until 2015, where only 7% of them are polluted and 8 of them actually are clean. However, what we notice is that after 2015, there are frequent chemical dumping in river, which occurs in Malaysia, and that incidents actually open government's eye on emerging pollutant and how emerging pollutant could affect the ecosystem in the river and at last to human health. So before 2015, where the frequent chemical illegal dumping are low, these are the most discussed problem. We have ammonical nitrogen problem and suspended solid problem that through animal farming, domestic sewage, and as well as land clearing. But after 2015, what happened with this illegal chemical dumping? There are many government agencies has came forward to understand about what are the type of emerging pollutant in Malaysian rivers, and that opens quite a lot of government research projects through grant, so that we can do the monitoring and provide them the database of the emerging pollutant in mainly in main rivers that supplies raw water intake to drinking water treatment plant. And then because of this incident, we have able to deliver this finding directly to the relevant environmental agencies. Okay, so in Malaysia, these are examples of main river, Langat River, until Sanggar River is the rivers that have been involved in emerging pollutant research. And these are the 6 emerging pollutants being reported. I think there are on microplastics in river 1 or 2 recently. I did not include here. Only these 6 emerging pollutant will be presented in this presentation. So when you look at all the papers or studies, including monitoring programs funded by government research agencies, the research are more into monitoring base because they would like us to provide the database in terms of pollution level and as well as risk. We do analyze in terms of human health risk and ecotoxical risk. Because the focus of government research grant is actually to have this database, there are very limited studies on transport and faith and modeling. They are more into relying on us to get the finding, the database part. So we have limitedly focused on transport and modeling. So we move on. Few of the example from each and every river that I've shown previously, so that we know the level of emerging pollutant from Malaysia. So Langat River is actually 78 kilometers long. It involves 3 states. It is also a major water supply to Kuala Lumpur, capital city in Malaysia, and then Klang Valley, a metropolitan area. However, although it supplies as a main water supply to drinking water treatment plant, it is classified as average pollutant. And we will see, these are few photos. It clearly show the rubbish, and then we do have illegal housing along this river, crossing 3 states in Langat River. Okay, these are the chemical illegal dumping that I've mentioned previously, and you see 2019 and 2021 records as the highest so far. And due to this incident, at least it opens government's eye to have a focus on emerging pollutant now, not only the common pollutant. So for organic pollutant, it started from Osman et al. 2012. These are the level, although it's still in microliter. This study has identified urban wastewater and industrial area that contributed the most for organic matter. And following that, Al-Odani et al. 2013 study has clearly explained that the detection of pharmaceutical in Langat River can be related or major caused by the sewage treatment plant. These are the trend where the level of pharmaceutical in sewage treatment plant and river. And this study has clearly mentioned that the inefficiency of this technology could contribute as a major thing where this pharmaceutical being detected. Okay, along with that, since we have squatter areas and then we have small houses along this river, they do have their own sewage septic tank which discharge directly to this river behind their house. So that could be another reason. Without any treatment, when the sewage reaches the river water, this is how the detection of certain pharmaceutical can be detected, and it is also closely related to removal efficiency. And we do have another study by Hashim et al. 2016, where this study has detected both two pharmaceutical, caffeine and diclofenac, in nanogram over liter, and this study has indicated that the consumption of beverages and food products contained with caffeine, and then through sewage, and then you have ineffective sewage technology that can contribute to the detection of this pharmaceutical. However, until this study, from previous study until 2016, a very limited focus has been made in understanding the risk. They only majorly focus on the level of detection, and there's no information on the risk present in the river ecosystem or human health risk. Similarly, this is the 2019 study. Although this study actually reports much lower than the number or concentration reported by Hashim et al. However, we do believe that it's nothing got to do that the pollution level has decreased, something has been done to the sewage treatment technology. Nothing is like that. We truly believe that the extraction that mentioned by Prof. Mukherjee just now, that could be the major reason. Different extraction method for river water and different sampling point by we et al. 2019. And again, we do have several sources that indicated the detection of estrogen hormone, pharmaceutical, pesticide, and plasticizer in Langat River. Again, even in 2019, there's little information available in understanding the risk. There's no any risk assessment being done. Now, we after pharmaceutical, we move on to steroid estrogen in the same river, Langat River, and we do detected certain range of concentration from non-detected to certain concentration, which although it is found low compared to other countries, but we do believe this detection could be due to the usage in livestock, could be due to inappropriate consumption and expired medicine which been thrown directly to dustbins. That could be few of the factors where this hormone have been detected in the river water. And in this study, we have managed to analyze the risk, potential estrogenic activity EEQ, where you can see when the values are lower than 1, it indicates that there's no any potential risk. However, we do admit it could include more estrogenic pollutant, so that this calculation could be more accurate, because this is just based on the steroid estrogen present, only one pollutant. We move on to the second river, Selangor River. Selangor River is located upper part of Langat River. You can see this is this river is located in location where you have agriculture activities. You have coconut, palm oil plantation, and these are the condition nearby rural area, and my right-hand side is nearby the agriculture area. And Leong et al. 2007 has reported the pesticides detected in Selangor River. Although the upper part of Selangor River is actually the water has been used for raw water intake. We do believe the raw water intake might consist of certain pesticides, which our drinking water treatment plant won't be able to remove those, because the secondary only involve secondary technologies, and the agriculture plantation actually the main cause of pesticide detection, and no information about the risk. We move on to another rivers. This is much more upper part of Selangor River. We have Selangor River, and lower part is Gombak River and Lui River. Among this river, Lui River is considered the most clean river in Malaysia. Gombak is the worst. We can see from this data, even United Nations Development Program has indicated that, this is one of the most famous and most polluted river due to these factors, and efficient drainage system, domestic waste, and sewage treatment plant. These are the main concentration of pharmaceutical in river water. And you can see among these three rivers, Gombak River is expected to be the highest. Okay, if you still remember the River of Life project, this is Gombak River in 1990s, where it just as the most polluted river in Malaysia. There has been few technologies which have been brought from Japan and few other countries, but nothing worked due to attitude problem, throwing rubbish directly to the river. So what happened is they introduced River of Life project. We do have NGOs along with this Department of Environmental Government people, along with, there are many universities around this area, and we do have school children and university children work together and conduct river cleaning project. So that works much more better than any technology, as Prof. Atul Koshla mentioned just now. So now this is the condition of Gombak River in 2021. Hope it remains. Okay, so these are the comparison between pharmaceutical concentration in various rivers in the world, and we could attribute the dexamethasone to be higher, which we believe it actually related to cattle farming and as well as topical use in medical field. And again, the inappropriate consumption, because we do refer to the report by Malaysian medical report, because we refer to the statistic of pharmaceutical being purchased and used, and this stands as the most used pharmaceutical in medical line. In this project, we managed to also analyze human health risk using human health risk assessment. There are certain toxicology value that is not complete, so we have to adapt from other organisms' value to calculate the potential health risk. We do admit there are limitations on that, but however, it's just to give a glance that human health risks do present due to pharmaceutical residues in river water. And then this is the ecotoxicological risk, meaning to say, due to diclofenac residues in these rivers, there are certain risks of ecotoxicological risk, which in this project, we did not analyze for toxicological effect directly using any model or any test, but we have recommended that for future studies. So when we complete the first part with the risks and then with the complete data, we have moved on to the second part where we actually collected drinking water where the raw water intake comes from Gombak River and Selangor River. We went to each and residential houses, obtained the tap water, and then we analyzed the tap water using in vitro digestion model so that we can obtain bioaccessibility form of pharmaceutical, and that's the concentration that we incorporated in human health risk assessment to calculate the potential health risk. At the end, again, since the toxicological values are not complete yet for pharmaceutical, we do admit that won't be the exact potential human health risk, but since we use the right form, that gives certain indication whether the risk present or not due to pharmaceutical residue. And this is from Low et al. 2020, where this study has managed to present antibiotic residue and compare his work with the rest of the world, and he do found that the usage of chloroquinone compound to be highest. I believe that he also referred to the same statistical medical report that we referred as a proof that the high usage and also related with slaughterhouse effluences that discharge directly to these both river, Larut River and Sangha Besar River. So from all these projects, including from other researchers that have done emerging pollutants so far in Malaysia, these are the 5 pollution sources that we have managed to give as a proof that it could be the sources that contributed to emerging pollutant release directly in the river water in Malaysia. And then due to all these incidents, thanks to the incident, so that there is an initiative where Ying et al. 2019 has mentioned that the Department of Environment, along with Environmental Health Unit, they do have some workshop to include emerging pollutant in National Water Quality Standard for Malaysia and also in Water Quality Index. That's the latest progress that we have been informed so far. So there are certain things in terms of policy recommendation, and this is just recently where all these researchers with emerging pollution data being invited. We successfully presented the table of all these emerging pollutant, and this has been approved at ministry level. So we are waiting for the update on the updated policy. They want to do something in terms of legislation. Okay, this is another top areas where recommended by Malaysian chapter 2017, along with policy changes. I think the main part we would like to do next is to target awareness campaign. There's no point, there are changes in policy recommendation, but the public doesn't know anything about emerging pollutant. At the same time, we do have our own challenges, which I believe chemical analysis screening technique and risk assessment tool, where the only few labs with high equipment can be used to detect, and that made our work much slower because we need to wait our turn. And at the same time, we do think mixture toxicity assessment need to be done parallelly together with any emerging pollutant, because that gives you a further understanding on the risk. So these are the loops where we found in terms of toxicology, where we need this kind of data so that our risk assessment could be accurate and gives you a better understanding. Again, these are just why we need the data, so that when we estimate the risk accurately, doesn't matter if it's human or ecological, it gives us another understanding on the impact towards health. Accurate impact to health and ecosystem. So with that, that's the summarized version of emerging pollutant research in Malaysia. Thank you so much.
Thank you very much, Professor Pravina. I think everyone in this room will agree with me that it was worth waiting until the end to hear to such a great research come real world experience talk. So thank you very much for sharing with us. Maybe we can take a couple of questions, or after this talk. So we have completed all the talks now, and in the original program we have that discussion time allocated for discussions. So anyone can ask question to any speakers, and it's like a brainstorming kind of session. So let's engage. So who didn't ask a question before, they are also most welcome now to raise questions, feedback for our projects, anything we can discuss. So it is open to all now.
Please provide your suggestion, questions, comments. We would be happy to receive that and improvise our further uh, further project. It would be really useful.
Yeah. So, Professor Propina, I have some queries regarding the um, uh, sample analysis. That is like we at the very beginning of the today's session we identified that this is one of the biggest challenges in doing research on these ultra low concentrations of this type of compounds. So, what type of methods, or for example, Professor Mukherjee, their group used the SPE method and then mass detection. So what type of detection method or sample preparation methods your group usually routinely apply?
Similarly, like Prof. Mukherjee, we do have extraction method, but I did not prepare here. But the method actually in our published paper is clearly mentioned. And for the analysis, we have applied similarly like Prof. Mukherjee, the LCMS, MS, and also ELISA kit, because since we use in vitro digestion model, so the end product that we obtain is actually something that already something that digested by human body. So that is actually a human product. So in ELISA kit, there are certain kits specifically for pharmaceutical that can be used to detect. However, what we found is that the recovery percentage for ELISA is actually much lower than LCMS. So when we have both data, it is good. But if we only rely on ELISA, like our first part of the project involving 3 rivers, I think that's the challenge that we learn. It is better to have what you call that ELISA together with equipment analyzing data. Then your data is powerful. We do have certain reviewer comment that they are not agree with the low recovery provided by ELISA. So we admit that. The second part, we omit the ELISA kit and analyze with equipment, and that's the data by Wee et al. 2009.
Yes. And regarding the human health risk assessment and also the ecotoxicological health risk assessment, would you like to shed a little bit more light? Because I think our 3 researchers who are working on the ground, so they have generated some data, they might be willing to implement some of these calculations.
Okay, for human health risk assessment, there are values that we took from USPA. All the values are in that published paper. But what we made, the exact value that we took is that the amount of drinking water that the resident drinks every day. That's part that we really emphasize in our questionnaire session. Similarly, I think by Himansu, I think he conducted questionnaire, right?
Rajiv, yes.
Rajiv,
yes.
So we included that we have one section on drinking water intake, how much of water he drinks every day, his body weight, which that's the exact value that we incorporated in human health risk. But in human health risk assessment, there are certain values which are which we don't have, like toxicological value. We did refer to USPA manual. I think all the values are in the published paper. Similarly, for ecotoxicological risk. I think ecotoxicological risk, we referred solely, taken all the values based on all the database available. So I don't think our estimation of ecotoxicological risk is accurate, but it gives you certain understanding,
Yes,
the
yes,
risk is present. But
of course.
I think globally we do admit for pharmaceutical, the toxicological part, especially the PNEC value is still in development stage.
Yes, yes, yeah. Like for metals, US EPA has more consolidated values. They call REF value or something,
Yes,
which they include. So,
but
but
not in this
organics,
case.
yeah,
Yeah,
organics and especially PPCP,
Yet not. They have.
a lot
They
of data needed to come upon such a value which is confident. Someone can use confidently. Yes.
And I think to incorporate together with that mixture toxicity would
Yes.
have been a great
Very
step.
crucial.
We
Very
really
crucial.
missed that part in our project.
Yes.
We should have included that from the beginning, so we can connect well our risk estimation together with the toxicity.
The problem is, the biggest problem is this analytical part. Like, for example, in our short duration project, we went for this HPLC DAD is because that we have in house. Like if we want to go to another lab, or if we want to use a mass instrument, a sophisticated one, I think this challenge is faced by numerous groups across the world.
numerous groups. Yes.
And when one compound analysis is so challenging, can imagine what is going to happen when we think of a mixture.
Mixture. Right.
And another thing I want to mention here, in our project, we have till now only the surface water and groundwater and drinking water. We don't have yet wastewater. The real challenge will come when we have the wastewater, because there will be a lot of dissolved organic matter, and that will immediately block the matrix. Even with the wastewater, as Professor Mukherjee mentioned, the SP is very troublesome, because there are a lot of organics and dissolved matrix, salts. So it's a very complex matrix. We till yet not have the wastewater. I think real challenge will come when we take the real wastewater, and then so really extraction and these are very challenging things.
Yeah, I think when we analyzed steroid estrogen in wastewater, we had a terrible stress time because of all these matrix.
Yeah, dissolved carbon and dissolved organic and dissolved.
And that's the first and last I would like to work with wastewater. And it's so difficult to get permission in Malaysia to obtain wastewater. And they control our data. We have to give the data and they want to modify it, and we feel like not honest at all when you modify. So I think that's it.
Various legal aspects are also associated with that.
And I have to sign few legal documents not to release this out.
Yes.
So that's the main point.
Any question? The 3 stars of our team, because they are working at the ground. So any questions for the speakers? Yes, Himanshu, I thought you were raising your hand, so you can unmute yourself.
No, sir, I don't have any question.
Okay. From our attendees.
Hello, am I audible, sir?
Yes.
This is Praveen Kumar Reddy from Manipal University. I'm a senior research fellow working with Dr. K. Balakrishna.
Hi, Praveen. Nice to meet you.
Nice to meet you, sir. So it was very good interaction session, sir. It is very helpful to the young researchers like us. So I'm currently working as a senior research fellow, and this is regarding the opportunities in this kind of collaborations in the coming future. So we have already published papers on pharmaceuticals, and we have worked on ecotoxicology assessment and so on. So I am going to submit in a very recent days, maybe in a couple of months, I'm going to submit my thesis. So it is I'm very happy to be a part in this, because with the help of my professor, I could attend this interaction session. So it is very happy to see, like I can see many presentations from different countries. So it is very nice to work with different problems, with different areas and different countries. So I would just like to ask and take an opportunity to request if there is any kind of good uh, opportunity to work on this multiple tasks. Can you please let me know, sir? Or like, is there anything? So I just want to know.
Sure, sure. Thank you, Praveen. Yes, I think one of the aim of our this networking event is to gather expertise and gather people together to make a consortium, a team of people, so that we can um, uh, address different aspects of the issue. And yes, we like who have attended today, we will be in touch with them in the near future. And when a suitable call comes up, we will try to formulate a project with multiple work packages. So each country or each country will give different scenarios, and then each research group can address a particular aspect of the issue, and that's how that is our kind of ambition or aim. That's what we want to do. So people like you with expertise will be valuable to our endeavor.
Yes. Thank you very much, sir. So I have a small experience in Japan also. I have went for an internship for 7 months during my PhD. Thank you very much, sir. Thank you for the opportunity.
Thanks, Praveen, for joining.
Thank you to all the professors.
And of course, Professor Balakrishnan joined at the very beginning. He had to go because of some other thing.
Correct.
But please convey our regards to him.
Sure, sir. I will write
be
to
happy to be in
Balakrishnan.
touch with you people.
Sure.
Yes.
Thank you very much. Thank you for the opportunity.
Anyone want to raise any other burning issues? Any advice for us? Okay.
Yeah, actually, I just want to.
Yes, Gopala, please.
I just want to say that it was mentioned by in the presentation during the presentation that the next step for your project work actually is to analyze the metal concentrations. Okay, so I mean, the thing is like I have the facility, okay, to analyze the metals. I have this ICP OES. Okay,
excellent.
So if at all any kind of help that is required from our end to extend, I think we'll be more than happy to extend anything that you can expect from us.
No, that's great. Thank you, Gopala. I think we need like the analytical facilities
Expertise. Yes.
and expertise. These are some of the bottlenecks for probably not only with us but several research groups in developing countries and other places. So of course, it will be a great help and a contribution.
Yeah, I mean, even apart from that, anything that you can think about. I mean, see, the thing is like already Shantanu, I think he's an expertise in this option. Okay, and I think if at all really we are thinking about to expand to the next level of this.
Sure,
project,
sir.
I think.
Sure, sir. I will be happy to collaborate, sir. Sure, I will be happy to collaborate with you. And sir, I am also working on biochar. So I think our area of interest more or less coincides in the similar area, sir. So I will be really happy to work, happy to write some joint project, to submit joint proposal.
Right. So I mean, the thing is like we can think about the removal part also, along with in the sense like having some eco-friendly materials.
Yes.
Yes, sir. Yes, sir. Sure.
So I mean, if it comes, and also the toxicity. When it comes to toxicity, that can. I mean, anything that you can think about. I mean, maybe we can have maybe another kind of a discussion, maybe another kind of a meeting.
Yes.
Meeting and.
Yes, sir. Sure. We will be happy to do so, sir.
We will definitely need follow-up discussions, and maybe not only one, maybe several before, because my ambition is to apply for a significant project. So to to fine tune our work packages, giving a holistic problem solving scenarios, including the socioeconomic, financial, the livelihood improvement and the technology intervention, as Professor Gopala just said, new methods for removing these contaminants. And especially, like, I liked your point, Gopala, that you said how to clean the entire river.
Yeah, that's it.
This most of these methods that scientists are developing, they work in the lab, they work in a pilot scale, like a filter system or so. But how about Ganges, river Ganges? That's massive. How we clean that? So social intervention along with the technological intervention. And we have seen the example, success example from Professor Pravina in Malaysia. So something like that.
Yeah.
Any other comment, or maybe then we can conclude. Shantanu, what do you think?
Yes.
Yes,
Yes.
please.
So now it's my turn. I know the most difficult job I have to do because it's almost end of the hour. So uh, we have so it was really a very nice and interactive session, and I must say we started with the Himalayan ecology and Himalayan system, Himalayan biodiversity, and then our honorable vice chancellor sir gave the example of Rhine River, Germany, and then we end up with the presentation from Professor Sarvamangala with the Gombak River cleaning. So it was really a very global view. So now we can see that water pollution is not only a local problem, it's a global problem. And as our Honorable Dean Sir, Vice Chancellor and Chancellor Sir has emphasized that now we have the water security issues and we should address this issue at all level. So just in upcoming few minutes, I'll be brief about what we have done and just what we have we have get to know from the presentations. So as from our ongoing projects with Lancashire University, we have seen that till now from the survey report that more than 80% of the BBN inhabitants are using over-the-counter drugs or non-prescribed drugs. We have seen the enriched concentration or higher concentration of norfloxacin, which is more than 100 microgram per liter. And we have found norfloxacin 2.2 times higher than the ciprofloxacin in the surface water. And from the presentation of Professor Mukherjee from IIT Mumbai, we have seen that there are negative removal. There are negative removal for some specific classes of pharmaceuticals, where we have seen that even after the wastewater treatment plant, these are not removed. Particularly, she gave an example of the carbamazepine, and she mentioned due to the deconjugation process and adsorption in the wastewater matrix, it gets much worse even after the removal. So, and also she mentioned the problem of extraction because of the water soluble, because of the matrix effect. We know that for organic compounds, it plays a big role, particularly due to the dissolved organic carbon, salts, and so many fat compounds, oils in the complex matrix. We have also seen the presentation from Professor Darba, where he has nicely mentioned the usefulness of the magnetic biochar for the removal of microplastics. We know that microplastics are nowadays become very prominent and in the river Ganges due to these different anthropogenic activities and our daily uses. These microplastics are also emerging. And he has mentioned the removal efficiency of more than 90% with this magnetic biochar. And also from the presentation of Gurjot, we have seen that microplastics can be act as a potential vectors of pharmaceuticals. And she pointed out a very important pictures of the interactions of microplastics and the pharmaceuticals. And she mentioned that these types of interactions are very much important for the environmental matrices. And we should not be only consider the adsorption kinetics. she mentioned the desorption kinetics or release kinetics. These are very much important to consider to have a long-term environmental effects of these contaminants, because these contaminants can have the slow release behavior. I can just point out one thing. When I was in Germany for my PhD, I know that the atrazine problem, atrazine was banned long time ago in Germany for pesticides uses, but then that time in 2016 they have the new problem of atrazine in groundwater, and it was coming from the slow release, because people saw that atrazine get bound in the organic matter in soil, but it was found that they are slowly released. So we can see that the release kinetics are so much important for the contaminants. And now we will have the global view from the Southeast Asian developing country, that is Vietnam, where Professor Lei gave us an idea about cyanotoxins, antibiotics, amoxicillin, and microplastics in the Saigon, Thao, and Tolij River. And she aptly pointed out the higher concentrations of these all emerging pollutants in the surface waters of the Hanoi city rivers of the Vietnam. Last but not the least, from the Professor Sarvamangala presentation, we have seen the River Life project examples, where she has mentioned she has given a good example of the Gombag River, where she has pointed out that how the Gombag River gets cleaned by the efforts of the school children. And she has pointed out the 6 emerging pollutants in the river of Langet, Louis, Sangor, and the Sangha rivers. And also she has shown and she has emphasized the importance of mixture toxicity to take as our toxicology assessment, which is very much important when we talk about the healthcare assessment. So our story is not finished here. We have done a very small thing of a big umbrella. So we have more things to do. So first of all, our future perspective is to do research on pharmaceutical care products in the aquatic and terrestrial environments. We should have a broader view and we should look on the broader perspectives. We have also planned to do a brainstorming workshop sessions with the academician and non-academicians and also the NGOs, and also involving the socio-economic persons, because from our Honorable Vice Chancellor to our Dean Sir, all have mentioned that it is very much important to consider the socio-technical perspectives and the socio-economics of the environmental remediations. We have, as already mentioned by Dr. Sharkar, we have planned to formulate future significant projects considering different international fundings like GCRA, Horizon Europe, and Asia Pacific Network Program. And we have also planned to do a proof of concept of sustainable water treatment technology. As our Honorable Vice Chancellor said, already mentioned, it would be really great to drink water from sewage water. How we can make sewage water drinkable, that we can see nowadays in, for example, in Singapore and in South Korea. They are doing that. Now we have to do, or we have to employ some technology whereby this we can build up the sustainable water treatment technology and we can drink the sewage water. Now also we should not stop here. The main thing is we have to formulate, or we have to plan the project from lab to land. We have to go to the people. So outreach activities and the livelihood rejuvenation of the local youth, that is very much important. So from our next projects, and we should develop some new technologies or some novel proof of concept that will also help for the outreach activities, help in outreach activities, and help in the livelihood generations of the local youth. So now it's a time to have vote of thanks and to show the gratitude. So first of all, I would like to thank our funding agency, UKGCRF, UKRI, and the Lancaster University for giving a fund, for giving us this nice seed grant fund, which helps us to do all kind of analysis and survey. And also, I am very thankful for to our Honorable Chancellor Sir, Vice Chancellor Sir, Registered Sir, Dean Research, Shoolini University, Dean our School of Agriculture, all the participants, all the invited speaker and panelists for their beautiful discussion, insightful thoughts, and nice remarks. And I am really thankful to all of you for your nice presence and for your kind presence. And please feel free to write to me or to Dr. Sharkar for if you have any questions or any comments or any suggestions. Now I am closing the session. So thank you to all of you. Thank you. Thank you. Thank you very much.
Thank you, Shantanu. So formally, like the formal session is closed now, but yeah, still, if anyone want to discuss any chat is absolutely fine. And yeah, I apologize again for the delay in the total how we proceeded towards the end of the program. So some of the formal things we cannot avoid, so we should be doing that. What is the time there now, Professor Praveena?
It is 9.
Oh my goodness.
It's okay. It's okay, no problem.
So thank you for staying with us until this late. And Professor Lay as well. I think in Vietnam also it is quite late in the evening now.
Yes, it's okay because the meeting is very interesting.
Yes.
Thank you. Yeah, and this scoping project they had very tight timeline they gave us, and we had to do many things in hurry. And how we thought of doing at the beginning, at the planning stage, something we had to make very significant changes in the way because of this pandemic. Because first 2 months of the projects we are not able to move. Our project researchers, they worked from home purely. So we had these challenges, but Shantanu and I, we really appreciate the hard work of those three people.
Yeah.
Like the moment they arrived to the campus, they were on the war foot.
Yes. Without their effort, the work would not have been possible. So really, they have done excellent job, no doubt.
All right, and we will be in touch, including a kind of a synopsis of our today's event, and then later on.
Yes.
Maybe...
As you know, perhaps that our Vice Chancellor told to make a proceeding of the event, so we will make that, and we will hand over to him.
Yes, and to think of some proof of concept type small research together, and that gives us a kind of kind of evidence to the funding agencies that we are already a team. So that is another thing that boxes we also need to tick before going to significant grant application.
Okay. Yes. And Professor Dorva, as I mentioned, I would be happy to work with you, and I will write to you for some projects or something like that.
Okay, bro.
Okay.
Okay, thank you very much everyone for attending and giving your valuable time.
Okay.
Thank you, everyone.
Okay.
Thank you, everyone.
Thank you.
Bye-bye.
Thank you.
Bye, Professor Praveena.
Bye.
Thank you, Professor Gopala.
Yeah.
Thank you, Professor
Bye, Gopala.
Bye.
Yeah.
Bye, Gopala.
We'll be in touch.
Yeah, sure.
We'll be in touch with you.